Mr. Khan, it is a pleasure to have you on. I think that the topic is so interesting, and it's very humbling to have someone with your expertise and your background, because you've worked very hard to get here. So can we start off with a little bit about yourself, your credentials, and how you got into this?
Thank you very much, Aaron, for having me. It's a great pleasure. I'm an assistant professor at Simon Fraser University in the School of Sustainable Energy Engineering. That's a bit of a mouthful. It's a very interdisciplinary program. And that was sort of the journey I followed. I did my bachelor's in chemical engineering, my master's in mechanical engineering, and my Ph.D. as well in mechanical engineering. So engineering has always been a theme throughout my education, and I felt that this was a great fit for me. And considering that, sustainable energy engineering is very diverse, and that's the kind of education that we should be giving now to the future generation for the challenges confronting us. So yeah, that's what led me here.
Awesome. If you just want to pull that mic up a little bit closer.
Okay.
I'd like to get right into the sustainable side.
Okay.
Because I'm interested in your thoughts on climate change. It's a topic that we hear a lot about, and as I may have mentioned to you, I feel like it's becoming a little bit more political.
Yeah.
And so I'm interested in your thoughts on what is climate change? What does it look like from your perspective?
Right. It is a complex process, and just by dissecting the phrase climate change, it is various forms of climate, which include, rainfall, include, conditions during summer and winter. These are all drastically changing, and the change, it's not, a sudden change that is, it's like, something that is coming in like a pulse. It's being seen over a long period of time. So over an average of so many years that have gone by, we have consistently seen temperatures rising, which is an indicator of climate change. So in a nutshell, the main sort of challenge that is coming from here is that the planet is warming. So as the planet is warming, it is not just causing, hotter summers, but also, as we saw, record-breaking cold temperatures in winter. So all of these are some, effects that are being brought in by climate change, but also, flooding, more forest fires. All of these are natural calamities that have always been there in our planet's history, but they've just been exacerbated.
Right. And so I think in perhaps normal circles, people who are not academics, who are not researching this daily, we discuss and kind of think about climate change in kind of like a smaller form way.
Right.
And perhaps it's more debated in the public forum than it is in the perhaps scientific forum. Is climate change as a topic, is it debated? I know you went to MIT. You've been to several high prestigious universities. Is this something that gets debated, whether or not it's actually occurring or not? Or do you feel like it is more settled within the universities?
Well, so in the scientific community, it is incontrovertible that it is occurring. And also what is causing it's clear with the evidence that the level of greenhouse gases in the atmosphere is too high. There's continuous injection of these greenhouse gases into our atmosphere. So the scientific community, very broadly agrees that this process is happening. Yes, there are, natural forms that, weather systems are affected, but the word here is anthropogenic climate change, so man-made causes that are causing it. And beyond the academic sphere, it's great to see that citizens around the world, everyone is taking this very seriously, and policymakers are also taking very seriously based on what we've seen with the COP conferences and different kinds of agreements that have started to come in. But yeah, it is always that interface between the science and the policy, and making sure that the policymakers understand what is the gravity of the situation.
Right. So when you're watching TV and you hear people debating whether or not climate change is occurring, from your perspective, what are your thoughts on that? What are you like? Is this frustrating where you're like, how are we debating this still? Like, how are you letting this person on? I know that Tucker Carlson had Bill Nye the Science Guy on, and that clip went viral. And people were frustrated because there were arguments made, you should have the overwhelming scientific majority in the room if you're going to debate it. It shouldn't be one-on-one.
Right.
What are your thoughts on that?
Yeah, I would say that for me, just being in this educational sphere, I understand that, that a lot of times you have to convince the harshest critics that something that you're pursuing is happening. And if you get overburdened by frustration, then the conversation that should happen gets diluted. So I would say that it is a sort of an art that everyone should be developing to convey the facts and then also convey what is the long-term prognosis of climate change in a very succinct way to anyone and anyone. They could also include people who are skeptical. But yeah, my thoughts there are that it just reinforces more the need for this communication, the need for having a broader message.
Absolutely. Can you tell us about where you think climate change is having, or where humans are having the largest impact in terms of climate change? Because I know that there are people who want to like buy more green items, and from like a skeptical perspective, I think a lot of that's marketing. Like it's a hot topic, and so certain things you're buying, they put on the little green stem, or they put something on there to make you feel good as a consumer, rather than it being a substantive solution to the problem. So where do you see those substantive problems?
Yeah, so these are great steps. I would say that, small steps like tracking your own carbon footprint and using alternatives that you feel are causing lesser impact in terms of greenhouse gas emissions. All of these are great, I feel. But also it's an important awareness that where is the main challenge lying, and it's that transition to clean energy and divesting ourselves from energy generators that are causing greenhouse gas emissions is very important. But also a realization that right now the levels of CO2 and greenhouse gases in the atmosphere are too high. And that realization is not yet something that can permeate into everyday life, because we don't have we can plant trees, we can maybe learn more about what it takes to capture the CO2 and take it out of the atmosphere, but in day-to-day life it's hard to have this permeating. But the other steps that you mentioned, sustainability initiatives that everyone's taking, they're all part of the mix and they're all needed.
Right. And so would you, like, I've heard it said that like you can try and get a green car and drive that for like a year, but then the second you take like an airplane anywhere, that you've kind of like negatively impacted overall. Where do you see the problem kind of standing out the most, where like if we can find a way to like make planes that are more green, that would have a giant impact? Where are those kind of bigger issues that we can start to have an impact on?
Yeah, you could broadly divide this into grassroots, like everyday citizens, like what are the efforts they can take to to reduce their own carbon footprint, and as you mentioned, things like buying greener things, using electric vehicles. All of these are great initiatives. But then there are also, as you mentioned, with flights, where it is more of another enterprise or entity owning that, and then citizens are using that. So there, in a way, choices are limited. Right now, for transportation, we have to use these fossil fuel powered planes. But that's kind of where this additional aspect of communication and knowledge comes in, and just by having these conversations, increasing the pressure on what technologies need to be changed and how quickly they need to happen. So there's that kind of indirect impact that everyday citizens can have.
Okay, interesting. So the problem seems to be too much CO2 from your perspective. I've also heard about methane.
Yes.
How do they kind of get categorized within the scientific community? Where do we, like, how big is CO2 in comparison to like methane?
Yeah, so that's a great question. So there is a term that's called greenhouse gas potential. So essentially, compared to CO2, how much are different gases contributing to to climate change? And on a very fundamental level, it's the ability of the gas to absorb some of these radiation that causes this heat. Now, CO2, as we all know, is a greenhouse gas, but methane has a higher capacity to cause global warming. And then also there are these other gases which are sort of also part of that mix that can have a higher potential. So nitrous oxide, for example, it's laughing gas. Its potential, I believe, is 100 times more than CO2. And then also another gas, I believe it's sulfur. It's a sulfur compound, which is 10,000 more. So if these are continuously emitted by different industrial sources, then they're also contributing to global warming.
Wow, that is very interesting. And for methane, watching documentaries on Netflix, my understanding is that often comes from the waste in our food that we like not eating. I think it's like an average, we waste like a certain amount of food every year that's significant. And so each individual wasting, I think it's like 30% of like what we purchase from the grocery store ends up going right into a landfill, is a huge problem because it doesn't break down naturally.
Right.
It's not in the forest where it's going to like biodegrade naturally. It's all compounded into one specific area, and then that gets concentrated and it has detrimental impacts on larger scales.
That's right. Yeah. And methane, you would, methane is also natural gas, for example, has a lot of methane as well. And there are naturally occurring sources of methane and natural gas that are always been there, always emitting. But also another source is the agriculture industry. So, cows, when they belch, they emit a lot of methane. And this is also now, you can see that even though it's a small amount from a cow belching, this amount is just so potent that it can cause a high degree of global warming.
And when you have like a ton of cows and each farm has a ton of cows, you're getting that higher concentration over time. And so it might not be just one cow. You have to look at the scale of how many cows perhaps in BC and how many times that's happening every day to kind of get a better understanding. Can we talk a little bit about CO2? Where does that often come from, and where are the problem areas of CO2?
Yeah, so for CO2, we could sort of categorize it into, sources that we're familiar with, but then also these sort of devilish sources that people have not heard about, but they also contribute quite heavily. So I guess like in the former category, you could say, transportation, heavy industries, all of these are big emitters of CO2 and energy generation. So a lot of places around the world still use coal for generating energy and electricity. When you burn coal, there's the CO2 that's emitted, and it's because it's so ubiquitous, there's such a heavy amount. That's one of the biggest emitters in addition to transportation. But then there are these so-called, fugitive emissions, which, are out there and everyone should be aware. So the construction industry, to make concrete, you need a lot of CO2. You generate a lot of CO2 in this process, and concrete is used everywhere for buildings, because right now, for buildings everywhere in the world, the standard has been concrete because of its ability to be strong and make these structures. But there is a high degree of CO2 that comes from that. And then also, other sources like the agriculture industry, like we mentioned, and many other, similar sort of industrial activities that cause these emissions.
Right. And so on like a scale, most people would be aware of CO2 and methane because that's something that they would daily contribute to a certain extent. And then you mentioned like nitrous oxide.
Yes.
And there's other ones, sulfur, that people would not be at the forefront of their mind.
Yeah.
Is there like a direction that you feel like perhaps governments or societies are taking to angle more? I've heard way more about CO2 than I have about the others, and you said that the others could be even more detrimental.
Right, yeah.
Do you feel like there's a public campaign to inform people about CO2 and perhaps other aspects of it more specifically, and then there's an equal kind of platform to push it on industries where we might not hear about? Do you feel like there's a good balance between the two?
Yeah, I would say that in terms of, dispensing the knowledge to the public, there are different means that, through briefings, through like what the government is going to be doing over the next 4 years in terms of their agenda. But I would say that knowledge about these, fugitive compounds that can also cause greenhouse gases that can cause global warming is limited. And, it's important to be aware that these also have a high potential, and where are they coming from? And overall, we have, as in the last, many years, always found alternatives. So when there was the ozone hole that had formed just over at the Antarctic, I would say like 30 years ago. There was a concerted effort from all the governments to find where is it coming from, where are those chlorofluorocarbons causing this, and what are the sources, and then to replace them very quickly. And it happened. And now, the ozone hole is relatively repaired and those compounds don't exist. So I would say that a similar strategy would also have to be followed in a very systematic way to find alternatives for whichever, mechanisms and industries that are using these other gases.
Can you tell us more about that one? Because I think that it's such a good kind of case study for people to put it into their minds that there's a lot of like conspiracy theories around climate change and the motivations behind it. And I think that that's such a good test case to kind of have a healthy dialogue on it, where you can go, there was this severe problem. My understanding was like mostly aerosol sprays.
That's right. And also, transformers and also refrigerants, these things, that used quite a high concentration of these chlorofluorocarbons. Now there have been replacements, and these replacements are still doing the job. They're still, causing cooling as refrigerants do. They're still being used, with sprays, as you mentioned, but they don't have the same impact with the ozone layer.
And so can you tell us a little bit about the ozone layer and why it was, because it stood out to people that they could see the problem. The problem with climate change is it's like a silent killer. You don't get to see it. You don't get to point at it in the same way. And people kind of try and point to natural disasters or issues within the environment as examples. But then you kind of have like the perhaps more right-leaning side of the spectrum kind of go, well, that's been happening forever. And it's less potent, where the ozone layer being withdrawing was very evident to, I think, anybody on the political spectrum. So can you tell us about that?
Yeah, so I would say that evidence, scientific evidence, is also similarly very strong for the CO2, that CO2 unquestionably is causing climate change, and unquestionably the man-made emissions are. And I feel I would say that, yes, there might be more that needs to be done to sort of like communicate that in a very reasonable way, to say that this is something to be taken seriously and why is it causing. So there are, simple experiments on YouTube that, people have been doing, where they can fill, one bottle with pure CO2, one bottle with air. And then if you have a heat lamp, and then if you have an infrared thermometer, you would see that the bottle that has CO2 is getting heated faster than any other gases that might be there. So those, are, seeing is believing is what a lot of people say. So with that kind of experiment, it's incontrovertible that this gas is causing that. So I would say that barrier between, these evidence and these experiments, and then communicating that in a succinct way, is something that can be enhanced around the world.
Do you think that it's been limited at all? I feel like certain topics within the scientific community, it's like, I've heard it said like, well, this is settled science. And I think that cuts... I had Karen Bondar on, who's a biologist.
Okay.
She's a very good science communicator. She's been on Netflix. She's been on National Geographic, different shows to break down what is the scientific method and what does that look like. And so the scientific method usually invites questions. It invites to be challenged. And so do you think there's any challenge at all with individuals saying, this is settled science, like you don't need to ask any more questions, because it is important to kind of show that? Do you think that that's made this issue perhaps more political than it needed to be, had we had the scientific community come out, break this down for everybody, show 15 different examples, and then kind of put it to rest?
Yeah, that's an interesting point. I would say that science is always evolving, and I don't think ever I believe that something is settled. There's always scope to keep discovering more, and then, the more you learn about the problem, the more you can brainstorm solutions. So I feel that that's constantly an evolutionary process, and science is evolving. But communicating those findings and finding, stressing on where the main challenge is coming from. And in this case, if we're saying it's the existing CO2, existing greenhouse gas concentrations in the atmosphere, then, we start to think, what do we do to address this? There's obviously the transition to clean energy systems, but then also reducing these CO2 levels is getting more and more prominent. But I would say, again, to answer your question, that it's very important to continue evolving science, having new findings, and as and when they're released, then being able to openly share it through different platforms that are not just scientific publications. Those publications are great for the scientific community. A lot of times they're not available to the public domain. So that's where sharing some of these findings. And in our group, for example, we believe a lot in visualizing things. So using color as an example to show that there's nuances in addition to the chemical data, because that's kind of where people see that things are happening. So I would say that should be also an area where that communication can be enhanced.
Right. I'm interested to know how much humans are perhaps impacting climate change. How much are we contributing to these problems? Perhaps on a global scale. What does it look like in terms of the increase? Because we had the Industrial Revolution, and it looks like things have just shot up from there. What does that look like when you're looking at the research?
Yeah, and there's an interesting graph that I'd found that a good friend of mine had shared recently, where it's if you see the increase in CO2 emissions over the last 150 years, and also the increase in the global GDP per capita, the shape of the curves almost exactly align, which shows that there is a one-on-one correlation between industrialization and growth and CO2 levels there. But yeah, the sources that I mentioned to you have been adding this extra CO2 beyond what the nature does, but also nature has built-in systems to sequester and take out the CO2, and they have not been able to keep up with this sheer amount that's been coming. And nature operates very magically, but it takes time. It's not a quick process. So even with reducing these levels, in a lot of ways, we flooded nature by adding the CO2. So yes, man-made emissions, it's called anthropogenic emissions as the terminology, has been contributing to climate change.
Very interesting. And so I really appreciate that you acknowledge the influence nature can have, because I think that that's something that perhaps past scientists or individuals from history did not recognize the influence or the power of nature. Like at one point in time, doctors thought the appendix was useless. And now we kind of understand that the appendix does have a use, and there is a place for it. But there was a certain, I guess, historic arrogance of like the scientists and believing that humans were smarter than nature and that we could kind of understand it and not need the influence of nature. So you acknowledging that just reminds me of my interview with Elder Eddie Gardner, who's very connected to nature. He calls trees the rooted ones rather than just trees. He talks about bugs as the ones that crawl rather than bugs, because you kind of get this like, oh, they're bugs, get it off me kind of attitude. So he has like that true appreciation for nature and the symbiotic relationship that we need to have. Can you tell us about what contributes to controlling the CO2 levels? Like I think it's trees, coral reefs.
Yeah.
Can you tell us about how that functions?
Yeah, and I very much agree that we, are in sync with nature. We are, living together. So that symbiotic relationship is very important. And that's why I would say that actually, scientists in, that area of science where they understand natural systems and flora and fauna have had that sort of dedication to show that this is how, nature processes things. This is how we can harness it. But yeah, there have been some incidents, as you mentioned, where there might be that overlooking of what nature can do. So for sequestration, one, the example most people are familiar with is trees and flora, and their ability to capture CO2 from the photosynthetic process. And that is a major carbon sink around the world. So the Amazonian forests, the forests here in Canada, everywhere, forests are just a magical source with which we can extract the CO2 from the atmosphere. But in addition to that, there's also oceans. So oceans have this algae that's called phytoplankton that has been for years been the carbon sink throughout the oceanic area around the planet. So a large majority of the planet is covered by water over land, and in those systems there are these phytoplankton, which are these tiny algae, have efficiently developed a process to photosynthetically capture the CO2 and then sequester it within themselves as a source. And then this is where the food cycle starts from. So they store it as energy, and then other marine animals and rely on that, and then that keeps going. But also the soil. So you mentioned about trees. So the trees, when they have the roots of the trees, there's these amazing fungi that are underground, and they form these underground networks. So a lot of times when the CO2 is captured by the tree, it goes into these fungi networks, and then it's sequestered there. So it's sequestered in the form of sugars, in the form of energy. And so all of these systems are quite amazing, and they work together to control the carbon balance.
That's so interesting, and I think gives us a greater appreciation for the environment we live in Canada, because
Yeah.
it is so green. I've heard it commented on by certain individuals that this is the greenest time we've ever lived in. There's more greenery than has ever existed before, partly as a consequence of the increase in CO2, because they rely on it. And so it's more of a hospitable environment for them. Do you have any comments on that? I know that people have tried to use that as an example of like, well, nature's going to fix it or something like that. So what are your thoughts on the increase in greenery that we're seeing?
No, absolutely. And that's important. And, planting trees and, starting from, around your own garden, like having seeds for trees that can provide so many benefits in addition to CO2 capturing is quite important, and they play a role. But as I mentioned, it's about the sluggishness of the process. So nature is very efficient, but then it also needs its time. So in order for it to, let's say, reduce these CO2 levels, whatever the level we're at now, to, let's say, pre-industrial levels, then you could think that, yes, you would need more of these trees. But then it's complicated, because the nature system is very intricately linked together. All of the land, water, and soil, they all have interconnected pathways. So it's very important to see the impact of planting many, many trees on what's going to happen with the ecosystems there. But in general, nature is very resilient, and I feel that that effort, in my opinion, shouldn't stop to continue planting trees.
Right. So when you see something like Tentree, which is a company that like I'm wearing a Tentree sweater right now, and I think they plant like 10 trees for every item you buy, or beyond a certain amount. Like if you have to spend $30, they plant 10 trees. Do you think that that's moving in the right direction, that we should have more sort of social enterprises offering those types of resources, and making sure that when industries like cut down a bunch of trees for development, we're obviously in a province where we use our lumber and we take it and we sell it to the United States or other countries, that they should be required to make sure that they replant those trees, and that we should increase the amount of greenery?
I feel that that's an encouraging initiative, and it's important because, if we have taken the trees away from a certain ecosystem, then it makes sense for me that we restore them back. But it should be done in accordance with a holistic picture of what's causing, climate change, and what are the impacts of, replanting trees. So I would say, for example, the Amazon rainforest, you might have heard 2 years ago they were severely burning, and the cause of the burning is still unknown, but there's a high likelihood that it could have been caused by a man-made fire that propagated. So in that ecosystem there, if scientific studies are showing that replanting trees can restore some of these deforested areas, then it makes sense for me that we put our efforts there in restoring what has been lost. And then let's say theoretically we restore all of the forests to whatever state they were. Then after that, we should see that where else could we use this land to replant more trees in accordance with what scientific studies are showing.
Right. I think that I'm interested in your thoughts on the Amazon, because that seemed like another case where it took longer, I guess, than expected for governments to kind of get involved. You saw the ozone layer response. It seemed quick and strong. And with the Amazon, I think that their government didn't seem interested in working with other governments, because I guess the citizens from there are tearing down the rainforest so they can succeed financially. I think they're tearing it down for like soybean farms or something like that, to succeed. Go ahead.
Yeah, so I feel that there are factors that have caused to the deforestation, and I do find it saddening that that this lung of the planet, in a way, has been reducing in area, and the authority to restore this is starts from the jurisdiction where they are. And I feel that there's been a lot of movements there, starting from, everyday citizens, from students, to bring this issue up to policymakers and make sure that they understand. But we do have barriers. And it is, it's important to, keep putting that voice there and making sure that the gravity of the problem is understood. And there are complexities. Every country is different. Every country's governing system is different. So that's very important that awareness starts from the very beginning.
Right. So where do you think that the bottleneck currently exists? Do you think that it's more in the impact on like individuals and societies in certain areas like the Amazon? I think of like indigenous communities, and it feels like we're constantly put in a circumstance of choosing between a pipeline that will help us get out of poverty, start to develop economically, versus protecting the environment. And it seems like a zero-sum game when you put them up against the two. And so do you think that that's one of the key bottlenecks, is that certain societies and communities have to sacrifice more than others in terms of making a difference? Because obviously the Amazon is a key, as you mentioned, you described it as like the lung of the earth. And so they have like almost more of an onus to impacting climate change than other communities where it's perhaps desert, where they're not really expected to do much of anything to play a key role in addressing these issues. Do you think that that's one of the bottlenecks?
Well, that's an interesting point. I feel that nature has carbon sequestration systems everywhere. Yes, they might be lower in a desert as compared to rainforests, but that's why, there's been a lot of wisdom that's developed over, centuries of communities that have lived in a place, and that wisdom is succinctly described, that we are in tune with nature. We know that what nature is giving us, and how we should respect the carbon balance, the water balance. All of these, even water as an example, is part of this, right? Because the water we have in our planet is the only water we have. We are not going to get water from the sun, not from any planet. So it's important that whatever water we have here, we're conserving it. But every community, there's ancient wisdom that has developed, and it's very important to preserve that, and to know that these techniques have existed for many years, and that knowledge is there. I feel that knowledge is there in every community. It might not be specifically climate change, but specifically how not to be wasteful, how to use resources in specific ways, and preserving that, I feel, is very important.
So do you think that this has gotten worse because perhaps we've disconnected ourselves from those belief systems, from those values? I think of like indigenous communities, and I grew up off of reserve. And so many of those teachings I didn't get to experience firsthand. And then there's a disconnect for so many indigenous people from those historic teachings. And I think that that's the case likely anywhere where you have ancient communities. And so do you think that those disconnects need to be reconnected as well if we're going to start to address this issue?
Absolutely. I feel that knowledge has to be brought back in front. And I had the great pleasure of visiting the Carcross and Tagish First Nations in Yukon in September. And by having conversations with the community, I was so amazed to see that that they've kept the air pure, they've kept the lands pure, they've kept the waters pure for so many centuries. And if you think about it, this is wisdom, and this is knowledge that now we need more, even more so. But in the way you could see that when the Industrial Revolution happened, and the motivation of those who started the Industrial Revolution, if you wanted to see like what was their overall goodwill motivation, it was to help humanity with things like more medicines that address diseases, produce on a larger scale, more availability of food that has nutrients fortified. But along the way, the impact that it can have on the environment may have been lost in certain cases. And this is where I feel that revisiting some of this wisdom and knowledge that exists from the past can be very helpful going forward.
Right, and perhaps reduce some of the divisiveness of these issues, because when you think of communities that have tried to live in harmony, it reminds you that you're like a steward for the environment, and that you like we are at the top of like the pecking order, but we have responsibilities to like
Right.
the fauna, to
Right.
phytoplankton. We have a relationship and a responsibility, and that should give us pause and hope that we have been able to figure out problems like the ozone layer before,
Right.
and that we have a role to play, and it's not something. I think of like how it's discussed when we have to make these sacrifices
Right.
as like a negative thing. It's
Right.
like we're giving something up, but it's really that we're just taking on the responsibility
Right.
that we
Yeah.
hold.
Yeah, I agree there, and it's very important that, and you know, in the kind of engineering teaching that we do in this program, we want to make sure that students know the ABCs of the engineering that they're doing, as you know, designing a plant, but then looking at the whole picture, like what is the impact on the local community, what's the impact on the global community of any project. And you know, it's a matter of minimizing the worst of these impacts while pursuing a course of action that might bring overall benefits. And you know, it is a complex process, but with a team that you know incorporates a lot of these knowledges and wisdoms that have existed for many years into the design process, can give outcomes that, as you said, you know, pursue that course of action, but then are in tune with the surroundings and nature.
Right. I hate to ask this, but I know in like the 1970s or maybe the 1960s, there was concern of global cooling, that we were going to go through another ice age. And again, this is used by certain pundits to argue that maybe this isn't the case, that maybe we're not experiencing climate change. From my understanding, it would be far worse if we were to go through global cooling in comparison to global warming. Do you have any thoughts on that because of how things have developed?
I'm not quite aware of that, but I would say that you know climate change is a complex, extreme process. So there are going to be extremes and global temperatures both on the hot scale and the cold scale, and it is important to know that these greenhouse gases are affecting both the hot side and cold side. So you know, often you may hear that it's the coldest winter we've ever experienced. What is global warming? Why is this? You know, this doesn't mean anything. So that's why, you know, the phrase climate change is important because it reflects that it is a complex process, and climate not just involves hot temperatures and cold temperatures, but rainfall and other forms that are all changing.
Right. Okay. So we're not like, do you think that we're not using the term global warming anymore, that we've switched over to climate change and that's better?
I feel that yeah, and I feel, you know, in a lot of languages from intergovernmental organizations and some of these, you know, accords that have started to come, the word climate change, the phrase climate change is the one that's used. And, you know, there's no planet B, for example, like just realizing that this is the existential crisis and it is just not beyond the warming of the planet. Yes, the warming of the planet is causing many of these because the molecules that are absorbing, they're absorbing heat. They're not absorbing something that is cold. They're absorbing these radiation that cause heat. But because of that, yes, there are extreme conditions possible. So one region heats up too much, there's going to be a flow of air, meaning that the region that the air is coming from may get cooler. So all of these dynamic processes are incorporated in climate change.
Right. So from your perspective, you have seen a variety of levels of government. You've seen the work that's going on. Do you think that we're moving in an optimistic direction? Do you think that we've got all our ducks in a row? Or do you think that much more education is needed in order to start to combat this?
Well, I feel everyone is always a learner. So, you know, always more education is something I'm very passionate about. I'm very happy that when, you know, people are taking the effort to educate themselves, and it's quite amazing that the young, you know, the younger generation are realizing that, you know, their generation is the one that is going to have to address this in a very systematic way. So, you know, the movements, for example, Greta Thunberg, who I'm a big fan of, you know, has started with Friday protests to make sure that their voices are heard, that governments are taking them seriously. So a lot of, you know, policy and decision making starts from that sort of grassroots initial, you know, those conversations that we have at our dinner tables that, you know, get magnified through these movements and voices. And it is encouraging to see. It is encouraging. I feel very optimistic that governments and, you know, through this recent accord that was in Paris in 2015 and Glasgow now, There were so many protests around the world, synchronized, and everyone had a clear message that this is the only chance we have to reach an agreement.
Okay, so let's get into your research. You're interested in carbon capture.
Right.
Can you tell us about what the heck that is and what it looks like?
One break for water?
Absolutely, go ahead.
Just...
Yes, because I think that it's so interesting that we're at a point in time where there is technology emerging that gives us hope, and it seems like it might be perhaps modeled after something like what nature is doing already, because the environment is already trying to capture the carbon in the best way it can. And it seems like your research and individuals work in like Squamish are trying to figure out how to reproduce that in a more effective way.
Right. So here in my research program, we're very interested in capturing CO2 directly from the atmosphere, but also from concentrated sources like industry as well as transportation sources too. And there, the big challenge is that CO2 is quite dilute in the atmosphere. There's 400 parts per million parts of overall molecules in the air. So in our group, we're very interested in using multidisciplinary approaches, a lot inspired by nature as well, by the photosynthetic process, because trees do it very efficiently. They know that there is this sort of drop in the pond effect with very small amount of CO2 in the atmosphere, but they're still able to very efficiently extract that and convert it into sugars. So now we want to think, how do we extract the CO2, but then how do we convert it into something very useful?
Right. And so what does the process of that look like, and how does it compare to nature?
Right. So in our group, we're very interested in using materials to be able to extract the CO2. And a way I like to describe it is like a glue. So if there's like a surface that is covered with a sticky glue that selectively absorbs or adsorb, the process is called adsorption, where the CO2 comes and sticks to the surface. So these materials then are not consuming energy. They're doing this spontaneously, because if you think about it, in order to drive some of these systems to operate, you have to process a large amount of air, and the atmospheric air right now is humongous. There's a lot of air in the atmosphere. So in order to process that and selectively take away the CO2, then you need to put energy. You need to have fans. You need to have systems. Now, what is operating these fans and systems is another point. If it is not driven by sustainable energy, then technically you're burning more CO2 to extract this. So this is where materials can offer a good respite. And this is something, leaves of trees in a lot of ways do that. They're not operating blowers, they're not operating fans. They're just spontaneously extracting the CO2 from the atmosphere by just using the chemistry that's in there. So this is something we're interested in mimicking.
Right. So I looked up the Squamish location, and they're interested in carbon capture, but it seems like they're more focused on like an air purifier, which it sounds like could have problems if it's not run by renewable energy or something like that. Whereas yours is like, for listeners hearing it, it's like having when you're trying to catch bugs and you put that little sticky thing down, and then the bug walks on, and then it gets stuck and it can't move, and that being done on a larger scale.
Right.
So what are some of the differences or challenges that you see?
I really respect those efforts here in BC where, companies have started to think about this. And as you mentioned, in Squamish, there's a facility that is directly capturing CO2. And I'm very fascinated by it. It is something that, is a technological challenge. And they have a process with which they're running a big amount of this air through a capturing system, and have shown that this is working through a pilot scale project. And scientific research in a lot of ways is meant to unravel what is happening on a very fundamental scale. So like you said, with the example of the sticky glue that is extracting CO2, in our group, we would be interested in understanding, how much of the CO2 is absorbed. What are the tweakings that we can do on the material surface? What are the embodiments we can use to enhance this process? Can we use temperature? Can we use other kind of knobs to make it more faster, to make it more efficient? And then the hope is that once, these scientific questions are answered, then they could lead potentially to a technology that can be, implemented on a large scale. And that's something that SFU and the program that I'm in has a very good ecosystem to allow for some of the ideas to come out from the lab and become into an embodiment.
Right. So how does it compare to a tree? How difficult is it to get there? Because I think of like the comparison of solar energy and solar
Right.
panels in comparison to a tree
Mhm.
that is able to absorb all of that energy.
Mhm.
And like you think of like the leaves, they fall and then they disintegrate into the
Right.
ground and then they feed the tree again. And like
Yeah.
it's a completely renewable process where
Right.
solar panels, one of our challenges over probably the next 25, 30 years is going to be figuring out, well, how do we recycle those and reuse
Right.
those into the future?
Right.
So how does that look in terms of carbon capture? Is it more effective, or are we going to get to a point where we're better at it than trees are or coral reefs?
Well, we can mimic it with the understanding that we should use everything in our toolbox. So if we have materials that are effective, we have systems powered by renewable energy that are effective, then yes, let's put that all in the mix to capture as much CO2 as we can. But as you mentioned with trees, right? They're very effective at this. The leaves have openings within them that are microscopic, with which they have this kind of gas exchange mechanism, and then very quickly with a catalytic process within the tree, they're converting this into sugars. Now we want to be able to. We're inspired by this, but it doesn't have to be a exact replication. Sometimes we may unravel something that maybe trees are not doing. So there, it's a sort of an interdisciplinary approach where we understand that there's gases involved, there's liquids involved, there's solids involved, and then how do we tune all of these in one place and then make it as efficient as possible.
Right. So the goal would be to have these carbon capture technologies located at industries that are severely putting out either methane, sulfur, or like, is it just CO2 that we're focused on?
That's a great point, and actually, I'm interested in beyond CO2 and more of general gas capture, and that's something that is unique for every different gas. You mentioned about solar panels. I'm actually one of the interests in our group is also to make these solar panel systems more efficient. So one of the challenges with solar panels is if you leave them out for many, many days, and there's dust and ice that starts to accumulate. And then once that accumulates, then it impedes how much sunlight can go into the solar panel. So we're interested in designing surfaces that are self-cleaning, that are able to withstand this accumulation of dust and ice. So that way solar panels can stay longer without more maintenance. And, again, this integration here is very important. So all of these technologies with photovoltaics, with windmills are all part of this overall, big sort of effort that if done in a very synchronized way, can lead to I feel very optimistic about it.
That's very interesting. So, what is it like in a day in the life of your research team? What does that look like in terms of like the questions that are arising or the problems that you guys are trying to solve, and how does that look? Because I think uh, it's so refreshing to have somebody like yourself on who's really working on these issues. Because I know people try and shop green, but to have somebody who's really thinking about these issues and looking at the environment and trying to take ideas from that to improve the systems so that we can get through this. I think that like you absolutely are a role model. We're lucky to have individuals like yourself in BC, but in Canada more generally, working to address these hard
I
problems.
appreciate it, Aaron. You're a role model yourself. I feel that this is important that we have these conversations and increase the awareness. For students in my group, the graduate students, they start off with taking fundamental courses, but we have these, brainstorming discussions where we see, depending on, what project or research interests they have, how we can tune those research interests and find a suitable project. So beyond carbon capture, my group is very interested in sustainable energy systems. So wherever bottlenecks to performance and longevity occur, how do we identify what are these and characterize these challenges, but then look at our toolbox and materials and in other sort of embodiments that we have to address these challenges. So students, are quite excited about making an impact in sustainable energy and climate change. So, but then fundamentally, we have to start with scientific questions, and that's where that brainstorming exercise comes in. I'm actually teaching a course this semester on chemical engineering, introductory processes in chemical engineering, but it's an elective course, so I've decided that with every lecture there will be some application-based questions on CO2 capture. So that's where students themselves are able to think, how do we utilize something like designing a chemical plant to efficiently capture CO2, and what are the calculations that need to be done? What are we up against? What are the outputs that we can get? So all of those are now integrated into this sort of traditional chemical engineering course.
Do you have an example of that for listeners who might not have any idea where that would start? Is this like a water facility plant? Like, what are the places that we can see starting to take those steps and looking at those measurements?
Yeah, so water treatment's a great example. So one of the things that we do in this class is, if you're looking at a body of water, let's say a lake, and if the lake is contaminated with pollutants, then you want to start to think about, how do we get rid of these pollutants, but then how do we understand this lake to begin with? So there with the lake, you want to think, what is coming into the lake? You may have rainfall that's adding the water to the lake. You may have a river that is extracting water away from the lake. So all of these affect the concentration and the amount of the pollutant that's in the lake. So we want to first be aware of what's coming in and what's going out, and then after that, think about how we can reduce that amount of the pollutants. And that's why you could think of it as a sort of a box, and then there's stuff coming in, stuff going out, and if the two are not balanced, then there's going to be accumulation. So that's kind of where pollutant can start to build up in the lake over time, and then cause toxicity, and have the fish and aquatic life would be impacted. But that's when now you can think that if the outflow, let's say the river and other mechanisms, are not sufficient, then what can we do? Can we add a chemical that can eat up this oil? Can we evaporate this pollutant? So those are the kind of questions. And then that similarly, you could think about that with CO2 capture as well. So the CO2 in the atmosphere is increasing because there's a constant source of CO2 coming from anthropogenic emissions, but natural systems are not able to keep up. So that's why it keeps on accumulating. So the in is not equal to the out. So that's where now you want to start to think, how do we can either stop putting the in and then increase how much we're taking out, so that way we're sort of controlling that. And those are the kind of things that students think about.
That's interesting, because I've heard discussions of like, we need to find a way to innovate out of climate change, because it's never really worked on like a mass scale to just ask people to stop using,
Right.
or to reduce their usage of whatever it is. Like the idea of like just taxing people to get them to get off of it is very difficult, because they're going to choose whatever is the easiest, whatever is the most
Right.
accessible. And so what is the kind of mindset when it comes to like the challenges of a human being, where we are so simple in our, well, this is the easiest way to go about doing things right now. I don't want something that's more complicated. Like, I even hear people complain that Tesla, it's like, well, its range isn't high enough, and it's like, well, like, we didn't have electric cars. Like, what do you want from them? Like, we're innovating in such a good way. And so, what are your thoughts on like the challenges of like, I guess the psychology of a person, where we seem to want the easiest way? Do you think that like the tax approaches are effective, or do you think that this is a lane of just innovating out, or maybe like a hybrid of the two?
And that's an interesting question. I would say that we all have basic needs, right? And every country, there are challenges that citizens have, and they want to in some we all want to care for our dependents. We want to make sure we have shelter, enough food and water and clean water. So these basic needs are always there, and it would be unfair to impose another need on people when if they're not able to satisfy some of these basic needs. So that's where there's a role that both the public and private sector should play. And with the public sector, you mentioned these policy instruments like carbon tax, for example, and enforcing that, let's say, on industries and bigger emitters of carbon makes sense to me, because that's starting from that those big emitters which consume, which emit the highest majority fraction of CO2 and greenhouse gases, can start to have the biggest impact. but then with, everyday citizens in our lives, there are these minute things that we mention, choosing greener alternatives, using electric vehicles. Now, those are also, there is going to be a time after they are implemented before we start seeing reduction in CO2 levels or controlling in CO2 levels. But all of these efforts should be appreciated and rewarded. So, if you are driving an electric vehicle, then it means that you have that capacity to do that. You have made that choice to do that. But let's say a family in a developing country that is working very hard to get food for their dependents. Then there you want to think that how do we start that process of changing their ways of cooking food and transportation and yeah, it's there is a big effort that policymakers and the private sector have to play in that way.
Right. I'm interested in your thoughts a little bit more on the carbon tax, just in terms of like where we're hitting now. Because if you look at gas prices for the average person, it's hitting that point where you don't really need a tax to discourage people from like driving with a gas vehicle. The prices themselves have hit that kind of critical mass. Like I think it's 176.9, which is just astronomical in comparison to when the carbon tax was brought in. It was closer to like I think 90 cents or $1 per liter. And so like, do you think there's a point, because now it seems like it's just going to detrimentally impact people in poverty, people who are barely able to pay for their trip to work or wherever they're going for their job? Do you think that policymakers are alive to the changing kind of economic world in a fast enough way? Or like, what are your thoughts on how government approaches those types of issues?
Yeah, so it is an instrument that policymakers use. And as I mentioned, I feel that, putting these on industries and big heavy emitters rather than everyday consumers makes a lot of sense to me. And I think that is an approach that can help to control some of the emissions from the big emitters. But also, some of these are, in a lot of ways, experiments. Like if it has been done in one jurisdiction and if it has been shown that there is an impact and then there is a change, let's say, in patterns with everyday citizens, then it can be, emulated around. But, undoubtedly, all countries are connected. There's a global economy. There's always going to be an impact, from one place to another. And I don't have an easy answer there. I feel like this is something that is fairly complicated, but what I would say is that every citizen in their own way, if they are aware and if they make those micro changes that they have, then it is reflected in an overall picture, an overall sort of concerted effort, and those should always be appreciated and rewarded.
Yeah, those decisions are scalable because if you're recycling more, which I think there was a big push for now, I think most people recycle, then if everybody does that, then there's a larger impact.
Right.
And so we can all kind of come together on these accessible issues to make the difference. It's not that hard to recycle.
Correct.
There's an incentive to, there's a disincentive not to, when you think of like the impact on the environment. From your perspective, how is perhaps BC or Canada doing in comparison to other countries? Like for me, I think of like BC Hydro, and it's like I don't think they get the credit maybe they deserve in terms of like we are just so used to having reliable energy that doesn't come from a harmful place. What are your thoughts on that?
Well, I'm very encouraged that, Canada, for example, released a hydrogen strategy recently, and there's a big push on hydrogen-based technologies and hydrogen energy. And hydrogen is an example of a fuel that is, when you burn it, it only generates water, so it's relatively clean. So I feel like, those efforts of transitioning from existing fossil fuels to more cleaner fuels, it's been encouraging to see the efforts Canada has taken, and also in BC with the starting from transportation, but also the modes with which electricity is generated. And we have to remember that hydropower has been a big part of Canada's energy mix, and it is one of the cleanest forms of energy. It is if you have a hydropower station that is extracting the water, again, if the project has considered all of the environmental factors, the impact everywhere, a hydropower project is a good example that is providing clean electricity, and Canada has been sort of a leader in that effort around the world. And yeah, it's been great to move to BC. I feel there's I've seen that, and people that I talk to with students, there's a very high degree of understanding and importance of what sustainability means, what it means to live in conjunction with the environment, and incorporate that in daily practices.
Do you think that that comes from like that we're surrounded by nature all the time? Perhaps maybe in comparison to Ontario, where you don't have the same level of perhaps greenery or
Yeah.
mountains or majesticness. Where do you think that comes from for British
Well,
Columbia?
there's the Algonquin Provincial Park in Ontario. I really enjoyed going there. There's also the Pinery Provincial Park. And, in Ontario as well, as you drive out of Toronto, you'll see that you're surrounded by beautiful trees and everywhere. Yeah, actually, it's an interesting question. The more I learn about living in Vancouver and BC, the origins of that, that's, I feel like, just back to what you were saying, right? It's like, it's conversations. If one person starts a good practice and has a network of understanding people around them, then, it's sort of emulated and reflected. I would say that that could be something in Vancouver as well, that, there is a high degree of, and BC in general, that there's that high degree of, let's see, this is the best practice someone's doing. Let's incorporate this, and then that leads to, again, a more global sort of acceptance of something. Something like the Evo car. I just came here in the car. That's it's a car rental service that I believe is owned by the province of BC, and it's hybrid electric cars. Anyone can have a car readily available wherever they are, and then you can drive anywhere, and then have a day trip or even like an hourly rate. But they are hybrid cars, which means that they are minimizing the impact that cars that are only powered by fossil fuels can have. So, that kind of initiative is very nice to see.
Right. On a little bit of a detour, I know that within the United States, their cities and perhaps their states aren't run off of something like hydro. And so one of the challenges they have is that you buy a Tesla in the hopes that you're going to have a positive impact, that you're investing in a green car that's run off of electricity rather than gas. But then one of the challenges you run into is that your house is powering it and your house runs off of natural gas. And I don't know if that's like a point where consumers fall off, where now it's just too complicated. Now you're just, I thought I was doing something good. Now I don't feel good about it. So now I'm frustrated. Within BC, our homes run off of like BC Hydro. And so when we power our car, it's almost like a fully integrated system that makes sure that we're being clean. And so you can be proud when you own like an electric car, that you're having a positive impact because your house runs off of green energy. And now your car runs off of green energy. And so it's a symbiotic relationship that means you're doing like a net positive. Do you think that that's like a challenge that we're going to have to overcome eventually in other areas like the United States, where we're going to have to switch over to like greener grids so that the green initiatives that consumers are interested in are symbiotic?
Yeah, that's a great point. I would say that it's important not to be discouraged by that. Like, an effort to get an electric vehicle should be celebrated. I feel that if someone has taken that initiative, it means that they care and they've done everything in their capacity to do that. If their neighborhood or jurisdiction does not allow for being powered by renewable electricity, then that's a constraint you have to work around. And that's where, again, the responsibility comes on governments to make that transition quick enough. And but I don't think that should be something that should demotivate citizens from making these kind of decisions, because it is to be celebrated. It is a great decision. If anyone, even if you install, let's say, solar panels in your house, and if that is powering some of these renewable banks of chargers that provide electricity, then all of that's great. And yeah, I feel like in the US, for example, in California, with the availability of sunlight almost entirely through the year, there are many homes that now are generating their own energy, electricity from solar energy, and then using this to charge their vehicles and provide power banks. So some of these models have started to emerge in the US, and that's going back to the example of a pilot project starting somewhere, representing good practices, then being emulated elsewhere. is something that I feel we've always demonstrated throughout, our existence and should be continued.
Right. What do you think of like the idea of energy independence? Because I know with solar, you can get enough power to like not only power your home, but to contribute back to
Right.
like BC Hydro, where you get like payouts from BC Hydro for
Yeah.
having solar. And I know Elon Musk is developing like maybe it's already on the market, like a battery
Yeah.
that you can put up against your
Power
home.
home. Yeah.
Exactly. So you can have that energy independence. So
Yeah.
when things arise in the world, whether
Yeah.
it's floods, whether there's problems in the environment where you're not getting proper power, that you are energy independent and that you can be confident that at least you'll have power. Do you think that that's something that we should talk, something we should encourage within people to be proud of, to represent, to be like, well, I'm independent, I've got my own energy, something that will incentivize in a different way people to consider getting solar panels?
Yeah, and in a very reasonable way, because as I mentioned there, everyone has needs, and that they have to prioritize that. So costs are a big factor, and feasibility of installing this. So I'm a bit wary about that culture that might start where someone has become fully energy independent, but it's costed a lot of money. It was they had that capacity to do it, great, but if it is not something everyone can do, then that starts to, if that leads to some sort of that resentment or something that this is not possible, then that's not in a good direction. So that's why a concerted role is important. So let's say if you do install solar panels, and if there is that appetite in the local jurisdiction to accept the excess electricity that's been provided, shared in the neighborhood, then those I feel that that's great. It's a step in the right direction.
Right. I'm interested to know, there's a federal government, provincial government, and municipal government. Do you think that there's a great amount going into each one, or do you think one's being perhaps underutilized or not using their voice as effectively as they perhaps could be to get different types of messaging out there? So like I think for like municipal governments that may be recommending to communities like, hey, make sure that your lights are LED, making sure that you're doing these things to like on a local messaging level. And then obviously we have the provincial and federal voices. Do you think that there's different roles that different levels of government can play in having different forms of the conversation with
Oh, absolutely. And again, going back to the overall picture, that if there is a good practice initiative initiated in a community, and if there is potential for a more broader adoption, then municipalities there are a great place to start, because they are able to understand the needs of their local community better than a more oversight government like provincial or federal governments. And then let's say from small initiatives like converting all of the public transit to fuel cells or something that's renewably powered, and showing that it is cost effective, it is something that it's not going to significantly change the prices that citizens pay to take the transit. And then presenting this in a conference or some kind of a forum where municipalities are learning from each other, and let's say municipalities in the same province then start to adopt that, then the provincial government also realizes this and provides more funding or more instruments to make it happen. And then if the provinces then get the nation's attention, then it's something that can be ubiquitously implemented. But again, easier said than done. All provinces are have their own governance, but again, I believe in a lot of this movement that starts from the very grassroots.
Amazing. I'm interested to find out your thoughts on individuals like Greta Thunberg, like Boyan Slat, who is working to try and clean the oceans. He's part of the Ocean Cleanup Initiative, where he's developed engineering technology to try and pick up some of the giant garbage patches that are like larger than the state of Texas in, I think it's the Pacific Ocean. Are there role models out there that you and your team look at and go like, this person has started something grassroots level to make like a meaningful difference that helps inspire your team?
Yeah, absolutely. We keep a tab on what's going on with not just scientific research and publications, but good practices and sustainability, And approaching that from the angle of how is the science here working, but what is the impact we can have. We also want to do more outreach. So now, unfortunately, with the COVID situation, it's been hard, but once things start to get better, going into school fairs and having these conversations with students, and in a lot of ways, everyone is inspired by a conversation, and that's where it all starts. And Greta Thunberg, for example, right? The effort, the initiative to start a movement, and captivate students, high school students around the world, who have done something similar, is just very inspiring to me. And then the example you mentioned about ocean cleanup as well. To put that in perspective, ocean cleanup is, not just about, let's just get the plastic out and let's make sure that the fish are not, having these plastics in their bodies and then affecting our fisheries and what we eat. But as we mentioned about phytoplankton, these are capturing CO2, and they need to be available in order to extract the sunlight. So now if you have this layer of garbage that's covering that, they aren't efficient. They are dying in large numbers. So I feel that effort, for example, is amazing, and it's something that is important that everyone's aware of it, and then then that starts to give you that stimulus, like what can I do? And then you realize that reducing your own waste is a good place to start with, and also participating in some of these efforts to make sure that policymakers know about this, are aware of it, and are prioritizing it.
Right. And I think that Boyan is so inspiring because he's also young, but he also realized that you have to go to the root of the problem. And what he realized was that it was adversely, like, certain communities in certain areas that were being the largest pollutants. And then so he started developing his technology specifically to try and catch the rivers and outflows that were going into the water earlier on, because some of these
Oh,
communities don't have access to like proper
that's
garbage
interesting.
maintenance.
Yeah,
And so
yeah,
he developed this thing that goes along the river that picks up a lot of that garbage so it never
yeah.
enters into the water. And I think that that's so motivational because you realize that he thought it through, that he wasn't just like, this is the problem, I'm going to fix it. It was like, well, where's the problem coming
Right.
from? And then working backwards to start to try and develop new technologies to prevent the problem from getting any worse.
Yeah, and actually now that you mention, I should include this as an example in my class, because it's another example of looking at inflows and outflows and accumulation. So, the accumulation of plastics will be high if there's a constant supply inside, but then, there's no stream to extract that. So I'm glad to hear that this person was able to find where the root cause is, and stop it at the source, and control then the amount that stays, and then extract that. So yeah, maybe that'll be the next problem set in my class.
Awesome. Do you look at any countries and think that there are things that we can learn from them, or certain countries that are setting like a really good example in their approach in comparison to even countries like Canada? I know we're on the right track. I'm just
Yeah.
interested to know if you see like a country and you go like, these people have figured out how not only to do it, but do it in a way where there's buy-in from the community and
Mm.
it's working.
Yeah, that's a great point. So I was actually in Norway and Sweden in November. I was able to get this trip in before the variant starts, and I was visiting universities in these countries and having conversations with scientists, presenting about my research and learning what they're doing. And yeah, I was quite inspired by the realization that, for example, in Norway, that they still have oil is still a big part of their economy, but then there's that conundrum that fossil fuels are causing climate change, yet they're a big part of the economy, yet we want to control it. So that was something that when I was having those conversations, I said very much so in Canada as well. We rely very heavily on our oil sands as a source for our economy, but that question comes up that is this in the long run, or is this what is the impact going to be on climate change? So I feel like Norway, Sweden, Iceland. I met someone from Iceland who was saying that they have a lot of geothermal projects there. Iceland, I believe, is fully renewable powered. It's one of the few countries that is 100% powered by renewable energy. I believe another country is Panama, or one of the Central American countries. These are amazing examples. If they've fully transitioned to 100% renewable power, that means that they've understood what renewable systems they have in that country, and they have implemented ways to extract that. So yeah, these role models exist as countries, and yeah, it's just great to see that there's also that passion within everyday citizens. Conversations in Norway and Sweden with taxi drivers, with people on the street. It was just great to see that they understand that yes, climate change is a existential crisis that's exacerbating, and we need to start making steps at the very basic level, but also be part of this conversation with our policymakers.
Yeah, I can't imagine the pride you would have as a citizen to think that you're part of a society that's not contributing to the problem, or have found a way to make sure that if any ways you are contributing have been kind of dealt with and planned for and responded to appropriately. Like I think that there's like I guess I could compare it to something like original sin within like religious domains, where there's like this guilt that I think many people carry in regards to filling up their vehicle or throwing away a water bottle instead of recycling it. Like there's a certain dislike for yourself that you have when you're in those moments, when you're doing things that if you could, you wouldn't. If you could stop yourself from contributing, you would. You just can't afford the electric car, or you can't afford to switch over 100%. And so I think that it would be nice to get to a place where we don't have that kind of weight on our shoulders of like, I wish I wasn't contributing to the problem, but I got to get to work.
Yeah, and that's a great point, because it is, you are living in a society, and micro efforts that you make, if the society rewards that, if they are so in Norway and Sweden, I got the sense that citizens are very happy to pay their taxes. They know that their taxes are going to be used by the government in a way that is coming back to them, that with infrastructure, with sustainability. I got the sense that they have that high degree of confidence. They also know that the government's doing their best to sort of, yes, every government jurisdiction has challenges, but overall there is that high degree of confidence on recycling, on sustainability. And yeah, I feel, back to your point about municipalities, this is a good example where, from a municipal level, because that's kind of a high direct sort of contact that citizens have as a first point of contact with policymakers. So if I would say that, municipalities are recognizing efforts and, creating that appetite that everyone's on board, everyone's doing that, then yeah, in a lot of ways it does help overcome that. And I felt that way in BC, actually. I feel that it's just great to be here, because the students I interact with, the policymakers, the private sector, they all know that what we are confronting. And how do we address that?
Yeah, it was very interesting to see something like the electric car movement, because before Tesla kind of came along, there was like a stagnation in the development of electric cars. There were hybrid models, but there wasn't that like big push. And then you think of where we are, and like the arguments were like, it's going to be too expensive, you're not going to want to pay for this. And seeing like the movement of Tesla to encourage the whole industry to rethink what it was doing is so encouraging. Seeing people like Boyan Slat, it's so encouraging to see kind of pioneers in industries where there was stagnation. There was kind of like a status quo mentality, and then that gets broken up, and it kind of revitalizes what we want to do as citizens and who we want to be. And I think that kind of like helps us reframe what the problem is, because we had like a national identity when it came to world wars, when it came to disagreements. And then it feels like more recently, we don't have that same national identity, those same core values of like, these are the things I want to prioritize. And it seems like right at the top right now is like, I want to be a good steward for the environment. And it's like, well, that's been missing for, it feels like so long in society, that movement is encouraging. And seeing young people set the example. I had Brian Minter on, who runs Minter Gardens here in Chilliwack. And he was talking about how like his largest demographic right now are young people in apartments wanting to find a way to make their balcony greener and put up trees and contribute in some small way to, and like realizing that when you're indoors, that you don't get the same air quality, that you actually benefit if you make sure you have plants and greenery in your home, because you yourself benefit. And I think just framing it in ways that encourage people and open those doors is very helpful, and like it builds confidence within that society.
No, I absolutely agree. And, that encouragement just reinforces optimism. And I feel everyone should be optimistic because, it is, yeah, there's a gravity of the situation, but it is, we have had groundbreaking discoveries that have made the impossible possible in a lot of ways. But I would also caution, everyone to, not be excessively, you know, to delve too much into what someone else has done, and in a way, like, if someone has taken all the possible efforts to be sustainable, but then the next day they take a flight to go to the UK, you might have seen this sometimes that people get criticized that, oh, you're a champion for the climate, but tomorrow you're taking this flight and making that decision. It's important not to get into that. I feel that it's everyone should have a reasonable judgment in what they're doing and utilizing the best possible knowledge they have, rather than micro seeing, like, if Greta Thunberg, for example, takes like a car to get to where she wants to give an important presentation, then the value that Greta is having and giving that presentation and spreading the word is quite important. And if that's the best available means to get there, if it is consuming carbon, there is a bit of a judgment there that Greta is involved. So focusing on that criticism there just dilutes the overall conversations. I would caution everyone to be aware of that.
Yeah, and just looking to kind of poke holes for poking holes' sake, rather than acknowledging that, like, she's likely not in charge of these things, that, like, we haven't revolutionized our air system to be able to be adaptable to the ever-changing landscape of the environment, and figuring out ways to have, like, green airplanes is a real, like, if you want to figure that problem out for everybody, that would be swell, but it's a real challenge that people are facing. In terms of renewable energy, what are your kind of, from your perspective of understanding the research, what looks optimistic? It sounds like hydro looks good, but I'm also hearing little spouts of, like, nuclear might be the way. And then I know that there's a whole public, like, there's part of the public that goes, like, we know where that goes. Where do you see kind of the advancements taking place?
I would say that a mix is important. And a good way I like to think about it is like with the COVID pandemic, when, vaccines were starting to come up. There was, a Moderna vaccine that was innovated. Then there was, the Pfizer and AstraZeneca. All of these sort of in parallel, they started to come. And then once we wanted to vaccinate the population, it was a mix of all of these, and it was found that actually all of them are effective. Yes, their main means of operation are different, but collectively putting them into the mix is addressing the overall challenge. So I would say similarly, even with renewables, we do need a mix at this stage, and we need to put whatever is providing that that source of energy should be part of the grid. Yes, nuclear, for example, is able to generate a higher density. So for the amount of fuel you put in and the amount of space that you have, you get a more higher electricity output that is, in a lot of ways comparable to the energy that we get from fossil fuels. So that's where it is important to realize that for some places, like let's say a mine that is operating in the middle of nowhere, where it is really hard to get that concentrated form of electricity, and conventionally, diesel or fossil fuels have been used, there might be an advantage there to use a small modular reactor that is able to provide that concentrated energy while contained in a very small environment, and then having the least possible impact there. So it's important that to realize that that is not should not be the only solution. There's a mix there, and yeah, a lot of research studies around the world are saying relative to a country where you are, depending on geographic proximity to other sources, which system can be deployed where. So there's a lot of, like, and I was in Sweden, as I mentioned. I saw a lot of offshore wind while driving across the coast. I saw in Denmark as well, there's a lot of offshore windmills. So there again, the local governments might have done that full feasibility analysis and seen that it's advantageous for us to have windmills not taking up land space, but then situated offshores. Yes, there's going to be an impact on the environment there, but the overall benefits are good. So I would say that catering those technologies to local areas is important, and also realizing the functionality.
Right. So would you say that those are, like, probably the top 3 steps forward is wind, nuclear, and hydro?
I would not particularly, be in favor of one versus the other in a
No, but
way.
like those are the three routes
Well,
forward.
I would not ignore solar. I
Okay.
feel photovoltaic technologies now over the years have developed significantly. The costs have gone down and they're very ubiquitous. Yes, there are some challenges as I mentioned with dust accumulation. So I would say photovoltaic technology is important as part of the mix. Wind technology as well, and then tidal energy, geothermal energy, for example.
Can you tell us about those?
Oh yeah, absolutely. So geothermal actually it's quite prominent from what I've seen in BC as well. So the idea there is that the planet has a lot of hot material underneath the crust, which is lava. Now this is hot, which means that you could extract this energy and then convert. And again, by extraction, what we mean is if you have another fluid like steam or water that is getting heated by this lava, then it can be used to drive turbines, which can then generate electricity. So as I mentioned, like Iceland, for example, they have a lot of volcanoes. They have a lot of like reservoirs where there's a lot of activity within the planet. So in a way, they've designed ways to extract this energy, convert it into steam, and then run their systems. But that again has risks. So geothermal systems have a lot of ions and salts that can clog areas. It can lead to safety issues within pipes. And interestingly, it was one of my projects in grad school. I'd worked with a company that was based out of Norway for like designing a system that can withstand corrosion and these kind of issues that happen. But yeah, that's also part of it, right? Every technology, yes, there's going to be these issues that start to come, but it's important that they are considered as part of the mix.
Right. So let's get into your education then. Did you always know you wanted to do this? What pulled you in a certain direction? What was your undergrad like, and what was your kind of mentality during that period?
So I loved chemistry always. I felt that chemistry, just fascinating to see things react and convert, and simple experiments like bubbling CO2 through a solution and seeing that it turns milky. Was fascinating because it's I'd done this experiment in high school and had seen that the CO2 that I'm emitting from my own breath can be extracted and converted into solid particles. And then I started to realize that solid particles are actually fairly dense, which means that they can sequester and store the CO2 in a mineral carbonate format, but then they're not occupying as much space. So then, and maybe these solid particles can be used for concrete. So yeah, I felt that chemical engineering was a good choice for me because my interest in chemistry and engineering, and I did my undergrad at University of Toronto, where climate change has always been part of the conversation for many, many years. And at that time, I remember some of the calculations we used to do with CO2 levels was, the assumption was always use 350 parts per million as a CO2 concentration in any calculation. But now, as you can see, it's gone up to 400. So, those things have changed in just a span of 11, 12 years, which is kind of crazy. But yeah, so chemical engineering there, it teaches you basics of how do you design processes that can generate chemicals and materials on a large scale for a bigger, sizable population. But that's where constraints come in, like safety considerations, environmental considerations. So I was able to get that holistic education there in chemical engineering at University of Toronto.
Wow. When did you decide that you were like a science type person? Like, did you grow up and enjoy school? Did your parents instill this into you? Where did the passion for education, but not only that, but like the science, that's where so many people drop off. I know almost all of my peers are within the humanities realm and within more in the criminology field.
Mhm.
They're not as scientific. And so where did that come from for you?
Yeah, and very much respect those who take these directions and follow the passion, right? And I feel that teachers make a big impact on giving you options. And so I would say my parents, my dad is an electrical engineer, so having that sort of engineering background in the family was very significant. But also my older siblings, so my brother and my sister, my brother used to work in Singapore when I was young, and he used to always send these cool video games from Singapore. And a lot of times the video games had some science component, which I always found interesting. I said, I just want to play the Mario game, but then Mario has to like overcome, carbon capture challenges and stuff like that on the way. So it was, I feel that was great to, have those models in my family to inspire me for science, but also teachers, right? So I feel the teachers who taught me chemistry, math, science. So in a lot of ways, I wanted to independently see if this is something I like, but also, ask those questions with teachers, be inspired.
What was it like for you to go through these experiences? Because I think of like some of the equations that you must have to do and some of the late nights that you have to study. Was there ever a point in time where you were like, this is a lot, like this is really difficult?
Yeah, I do feel that, there's, this thing with engineering students and university that just accept that your calendar is going to be fully packed 9 to 6 and then working together. But, that community feel is great. So having peers who are also in the same boat and working together on problem sets, working together on, that sort of reinforced for me that, everyone is similarly passionate, but we all recognize that this is the model that we have to follow and have trust in the system. So the educational system now that I'm on the other side as a professor, I see that we design a curriculum with that in mind, that we want to give the students this particular background, but we understand that yes, it can be quite intense, but then a lot of times these students, they appreciate this many years when they're into their career, that this the time management skills you get from it, working in a team and having a lot on your plate, but being able to balance that. That's something I found very very inspiring, again, from engineering education.
Right. So you ended up going to MIT, and for listeners that don't know, that is one of the most prestigious schools likely in the whole world, and particularly for engineering. I am a huge fan of Lex Friedman, if you know who he is.
Yeah.
He's got his own podcast.
I believe I met him once. Yeah. He's a teacher. He teaches courses at MIT.
Yeah, and I just think of like, I just listened to his interview with Elon Musk on his podcast, and it's just so humbling to realize that individuals like yourself, engineers, the mind that you bring to problems is so far from, I'd say, like the norm, from what people in their day-to-day, just doing their 9 to 5 jobs, are used to, because you're looking at things from first principles. You're trying to work through complex, multifaceted problems and meaningfully engage. And hearing Elon Musk describe the challenges of developing a rocket that's going to be reusable and the challenges that are going to come with that, it's very humbling for someone like myself to be able to sit down with you and to hear your perspectives on these problems, because it takes a large amount of work in one of the most premier schools in the whole world. What was that experience like to go to MIT, to be accepted and to start attending and to start to have individuals like Lex Friedman become your peers?
I'm just very privileged to have had that experience, and I remember that when I got the acceptance, it was just sheer disbelief, like how did this happen, and must be spam, and have to figure out what to do. But yeah, I feel that experience of meeting very inspirational people who are similarly passionate about anything. It doesn't just have to be engineering. MIT has a lot of programs in humanities as well, but whoever was there had that degree of passion that they chose to follow this and go there, and I call them my classmates, my friends, and it was great to be in that kind of environment there. But also, I feel I appreciate what you said about engineering, and yes, it is a kind of curriculum that we have where there's a high degree of putting your hands into different fields and synthesizing everything you've learned, and it's given that ability to to help look at problems in a more holistic way. But yeah, befriend an engineer if you know an engineer. Just even if you've not you haven't taken engineering, just by having someone who's been through that in your friend circle, you just learn a lot of things. And likewise, the engineers themselves also learn from everyone. And I feel that you can't learn everything in a university. So having a broad circle of friends and colleagues who, are studying policy, for example, or, humanities, you start to exchange these ideas. And in a way, through that interaction, you learn. So that was kind of a good part of my experience there. There's just so many programs. I also I did a master's in technology and policy studies, which which was a sort of interface between this engineering and bigger picture societal challenges. And that's where, those conversations started to make me think that, engineering is not just about the math and about, designing things, but there's a bigger impact, and conveying that to people is very important. So, surrounding yourself again with friends who may know more about policy, may know more about, humanities and other considerations is very impactful.
Really? Okay. So can you tell us about what you see as perhaps a chemical engineer or just an engineer? How do you go about looking at problems or thinking through things in comparison to others? Like, how did they kind of instill the process of thinking for you?
I would say that a lot of times there is a specific need that is identified, and then a response to that need results in an engineering project. So, something like building a bridge between two cities that goes over a river. You could say that that is a need. The local communities need a better way for the transportation. So that is something I feel that all engineering programs around the world are infusing in their curriculum. That how do we make sure that students know how to identify a need, and then after that, how do what is in the engineering toolbox to address that need. And that's where engineering has different disciplines. So there's civil engineering, chemical engineering, mechanical engineering, materials engineering, nuclear engineering, bioengineering. All of these, then you can think that they teach not just the need, but then specifically within that sector, like in bioengineering, for example, tissue, artificial tissue, or maybe something that can be inserted and has compatibility with the human body, like an artificial hip. How do you design that? So that's again a response to the need that someone wants to have that, but then wants it to be safe and sustainable through their lifetime.
Right. And how does that compare to chemical engineering? What are you seeing in comparison to, I guess, a bioengineer?
Yeah, so chemical engineering is the ubiquity of applications is enormous. So that's what really excited me. And I can say for my classmates as well, we were all very inspired that, it's not just like, let's design this process to make, hydrochloric acid or sodium hydroxide, but areas like cosmetics, the cosmetics and shampoos that you see in the aisles and superstores and grocery stores, they come from a process that has been designed by process engineers and chemical engineers. So there has to be some, raw material that goes in, some energy that goes in, and then you get this product. But then you want to think like, what are the wastes that come out of it, and where are these wastes going, and how are they impacting the environment, and then how much energy are you using? So this entire balance is a part of a chemical engineer's daily life, and the applications are enormous. Some of my peers work in finance because some of the concepts in chemical engineering, like in and out, you can apply that to finances. How much money is coming in, how much you're saving, where are these financial resources going? Another area of application is medicine and pharmaceuticals. So making, and especially now in the COVID pandemic, we saw that if you want to ramp up some of this production of critical medicines, a lot of people don't know that these medicines, in order to make them, the chemicals needed for that come from the oil and gas industry.
Right.
So the oil and gas industry is not just to provide fuels to run the car, they also provide some of these chemicals that go into making polymers, go into making medicines, and they are right now the only source that provide those chemicals. So again, how do you design this in a systematic way is what chemical engineering teaches.
Yeah, I recently listened to somebody who was breaking down a little bit about what you're talking about in terms of like what fossil fuels create in terms of our plastics, in terms of like so many things, like likely this whole microphone, everything that we kind of take for granted comes from these things. And so the challenge is, I think, far deeper than some people realize when they think of just switching over your vehicle, is that like so many things that we use every day, from like everything developed in our car has to come in some way, whether it's like the plastic outlining of something comes from fossil fuels and comes from the extraction process. What was that like for you? And when did you perhaps decide that you wanted to go into like working on sustainable energy?
Yeah, so I realized that in my third year. So University of Toronto offered a minor in sustainable energy. At that time, it was a new minor that had just started, and I looked at the curriculum and it was still novel. They were still trying to make some courses around that, but I took a course in learning about the vast terrestrial energy systems we have, and that was great because as we discussed, geothermal, the planet will surprise you. There's just so many amazing systems that can be harvested. Tidal energy, for example, if there's high tide, low tide, the moment that comes in, it's a huge burst of energy that can be extracted. But also things like lightning, thunderstorm. There's like tremendous energy that the nature has that is reflected in these processes. So it was very fascinating to take those courses and realize that sustainability, sustainable energy is a right choice, is something that I want to pursue. And climate change and talk around this has always been there, and as I mentioned, it's always been infused in curriculum, and people have known about it. And that's something that I was very happy to see, that engineering programs are starting these minors to complement what traditional programs like chemical engineering are doing. And now, we now have at SFU this program that is fully dedicated to sustainable energy engineering. It's not chemical engineering, mechanical, but it is a 4-year program that is very specific into that.
Right. So when you were going through at MIT, what was your kind of plan, or what was your thinking to go from there? Were you you were nearing the end of your PhD? Where were you thinking of going or taking this?
When I was nearing the end of PhD, it was like I'm done with academia. I'm done with it. I just want to finish my PhD, and at that, I made a decision very early on. I wanted to return to Canada because I felt that Canada's home, and it's great to be back and use what I've learned here, and but actually, I was very interested in a more policy-oriented career where I'm more, interfacing with policymakers and, writing briefing notes on scientific topics, and that's why, I was very lucky to work at Natural Resources Canada, where I was directly advising the chief scientist of Natural Resources Canada, and that was about 3 months after I'd finished my PhD. When I'd returned, I was, applying for jobs, talking to people. So I had a chance to network with the chief scientist at a conference, and that conversation led to this opportunity.
Right. Can you tell us what you did in your PhD? And please don't be afraid to make me or any listeners feel unintelligent, because I think it's valuable to be humbled by what we don't know and what we don't understand. And so there may be parts of what you're explaining that I don't understand, but I think that gives us a further admiration for the work that it may have taken for you to succeed at this, and then for you to be in the role you are today. Because at this point in time, it's like, it's so valuable to understand what you had to learn in order to be contributing to the scientific knowledge.
Yeah, and I love talking about the research that I did. And it was, when I started at MIT, I was working on, materials that resist water, so hydrophobic materials. The kind of materials that in Vancouver you have in, jackets, and it's very advantageous to have quick shedding water from the rain jackets. So those materials, another thing that traditionally they've been fluorinated, that have a big environmental impact because fluorinated compounds, they persist in the environment. Natural systems don't have the capacity to degrade them. So a lot of times, actually, you might find that fluorinated compounds in rain jackets end up as far away as places like Mount Everest. At the peak of Mount Everest, people have detected some of these compounds that have been in rain jackets, and then you wonder, how did this end up there, and how long has it been there for, and now how do we get rid of it, because it's there, and then that's infusing into systems. So in my master's research, we worked on we were working on some materials that are non-fluorinated but then have the same kind of hydrophobic properties. So that was very interesting, and that sort of got me into the sort of chemistry and material side of things. But then I also did this program in technology and policy, so that's where I was thinking more on how do you obtain these materials, what are the processes, which countries even have these materials, and then what needs to be done at a more bigger picture level to have the supply meet the demand. So it was good to sort of synergize those two, have that scientific research along with the policy end of things.
Right.
But then after that, I figured that, for a more, in-depth science, it's important to, become an expert in a topic. And that's where the PhD made sense for me. So I did my PhD in mechanical engineering. But also my PhD was very diverse. So traditionally, a lot of PhDs, there's a particular focus topic, and then you have multiple papers in that topic, and you become that expert in there. So for me, I was very interested in interfacial science, which is this, as I mentioned, the boundary between two materials and impacting those interactions. So I thought that if that sort of is my theme, then there are interfacial interactions in many different areas. So in CO2 capture, in geothermal engineering, as I mentioned. So that's where two of my projects were very heavily involved on protective materials to withstand corrosion and damage that can occur in pipes and systems, especially with geothermal. So as I mentioned, this geothermal fluid has a lot of material that, as you have boilers, when you look at boilers, you can see that there's a crud of material that starts to accumulate, white stuff that are salts, and over time, it just renders these useless because these salts just clog up everything and they stop the fluid from flowing. So that was something that was interested in. How can this be controlled? How can corrosion stop? And so that was where one area of expertise developed. And then the second area was CO2 capture. So I was very interested in electrochemical processes to capture and convert CO2 into fuels and useful materials. But they're also understanding that, there's a big realm of science on the chemistry, but, if we look at it from the side of interfaces and how gas bubbles are interacting in solutions, how can they be captured? How can they enhance CO2 then? So that was another area at the end.
Wow. So for the corrosion one, how do you go about fixing that problem? Like, how do you go about thinking it through to find solutions? Is this like we just need a different material, or we need to develop a material, or like what is the process to start to try and address the issue? Do you have to read a bunch of research in order to see which materials have been used in different countries? Like, where do you go about kind of addressing it?
Yeah, so a lot of things you can look at with everyday examples. So if your car, you don't want the sides of the car to corrode, then typically it's coated with some layer. So there's some kind of coating that prevents salt water from interacting with the car, so causing corrosion. So a common approach is applying a coating, and if you apply a coating, then that barrier coating stops corrosion from happening. But then you can think that if someone was to key your car and like start to make scratches, then no matter how good the coating is, if the coating starts to have these cracks and defects, then water can go in and then cause corrosion at the underlying metal. So that's kind of where we were interested in having materials that are self-healing, which are able to, repair themselves. So even though there's some kind of a damage, then there's enough of a fluidity in the coating that it comes and heals up these areas so that way, you can stop the corrosion from happening. So that was the focus of one of my papers where we studied liquid layers. So it's a little counterintuitive to think that liquids can make good coatings, but there are systems in which you can have a thick layer of oil, which is very protective and it covers the surface. And then because it's a liquid and because it has these, fluid properties, even if there's like a scratch or any defect, then it can heal it. So that was the kind of approach we followed. And it was great because, corrosion has been studied for many, many years. And the corrosion community has, understood that, yes, there are challenges with solid coatings, but these kind of ideas, when they come, then they can be catered for different corrosion applications.
Right. I think that's just so valuable because I think that's where like it goes back to first principles of like most people would think of a solid coating. I would never in a million years guess like maybe we should make it liquid. Like
Yeah.
you would never think about that in your day-to-day life, where as an engineer you go back to like, well, how do we find the best solution? And it may be like not part of the norm. It may be outside of kind of the expectations you have in your home, because you would never want something liquid in your home to
Yeah.
prevent that. So you take that kind of assumption and you bring it out into the world.
Yeah.
Where in your field it sounds like you were like, well, nobody's gonna like be around here. It's not like people are gonna be like licking it or anything. So what can we develop that's
Yeah.
gonna be effective?
Actually, it's interesting you mentioned, but one of the things that if for those who cook, if you have a cast iron pan, And a common thing to do at the end, just to preserve the longevity of the pan, is to apply these seasoning oils.
Right.
And then if you put that oil and you season it, then it is a process with which corrosion and damage is prevented. So this is an example of a liquid coating. It's a very thin coating, and it is able to now protect it. But what we found is that even with these coatings, there are challenges with, the interfaces and the level of texture and chemistry. So it needs to be designed in a very systematic way.
Yeah.
But such a thin coating is able to able to provide corrosion protection.
That's so interesting. So when you meet with, it was the head of one of the heads of the Canadian government in terms of natural resources. What was that meeting like? And was it a unique experience to be offered a position to be like an advisor? Like, what was that process like to kind of say, like, I'm going to be like influencing how our federal politics and our federal decision making is going to take place?
Oh, it was amazing. And, it's just so humbling to see that, these individuals also, have something that they've been passionate about, their story, and how they've tried to incorporate that level of bringing new knowledge into the government decision making, and then that art of managing different players in a decision making process. So the chief scientist has always been a great mentor and a friend for me, and we still are in touch. And they, their main expertise and background was in artificial intelligence and data science. So bringing that into Natural Resources Canada was a big sort of focus of their team. So yeah, networking is something I encourage everyone to do. It is that there is a sort of a barrier sometimes that people feel that, if you go up to someone, you may say something dumb and, it may turn off, but always, evaluate the risks of that and see that, the benefits that you may get are higher. So I would say that, it's unfortunate now with COVID times that art of networking has been limited, but now hopefully as and when, with other means like LinkedIn and all, if you reach out and it's just all a conversation. So similarly, it was a conference that I had attended right out of my PhD. I was, I wanted to say that, hey, I've come back to Canada. I want to be able to use what I've learned, but also have, some impact. So it was all a conversation with the chief scientist. It was very, we connected. We had similar things we connected on. They went to Harvard, and we spoke a lot about, things in Boston and all. And that rapport was developed. And then after that, they offered me this position, and it was intimidating because it's, being an advisor to such a high, such a respected person. But that's kind of where, adaptability is very important, because the moment I started the role, the pandemic happened. And then I realized that a lot of my role then was also realizing what is the impact of the pandemic on the way we do science? What is the impact of the pandemic on economic recovery in Canada? So it changed the course of my time there. And a lot of times, as I mentioned that example about the petrochemical industry providing raw materials that are needed for medicines, it was, making a case for that and saying that how, the petrochemical industry should work with the pharmaceutical industry to ensure we have that supply. If at that time the pandemic was very uncertain. We didn't know how much we would need medicines of, was it just a vaccine that would address it? So all of those, cases that no one had ever thought about, where we would have to ramp up so many medication prescriptions and make it available to all of Canada, was so important. So those are the kind of, decisions, and those are the kind of like information sharing I had a role to play in.
Right. Was there any other questions that you were involved in during your time there that stood out to you? Like, what was that experience like to bring your knowledge base to that position?
Yeah, I would say natural resources in Canada encompasses, forestry, mining, and a wide variety of sectors that Canada has always been proud of, right? So Canada is a vast country. There's been many natural resources that have been used for certain purposes. So one of the things that the chief scientist was very interested in is how can we bring digitalization and artificial intelligence and advances of these into traditional sectors like natural resources. So that would mean that, with a mine, for example, if you're extracting minerals and metals from a mining facility, then traditionally it's operated in a way that, yes, you have a machine that is digging up and extracting this ore, then it's been processed, and then you have a hydrometallurgical process to extract them and then convert them into metals that can be used and shipped. Where can AI, where can digitalization have an impact there? So it was great to, because I had actually worked in the mining industry for a year right out of my undergrad, and I had some background knowledge on what is the mining area in Canada looking like, what are some of the metals and resources that we have, and then traditionally how they're used to how do we extract them, but then what is the potential for digitalization and artificial intelligence to impact that. So creating that interface helped in my discussions with the chief scientists and then also the scientists at Natural Resources.
Right. It might be outside of your field, but was there any conversations about what was going on with the discussion of bringing the pipeline through? Was that something that had arisen during your time there? It might have been prior, thinking about the pandemic. And what was the thought process there, if there was any?
No, my area was to, again, with the pandemic at that time, there was like um, it was sort of like a role that I felt that it's just I have to do this. I have to see, we are in uncharted territory. The pandemic, it's nothing like this has happened, and we can't just shut down mines, and all of these critical operations still have to keep going. So a big part there was also realizing that I've worked in a lab before. I've worked in a sort of a hands-on environment. So in a hands-on environment, how do we if we have to enforce social distancing, if we have to ensure these protocols, how can we still keep innovation going? How can we still keep these processes running?
Right. Can you situate us, I guess, in how science within somewhere like SFU or the development of research impacts like broader industries, impacts society? Because I think that's where academics like yourself and individuals researching things, I don't know if we as a society are able to give credit where it's due in a healthy way of saying like these are our people working day in, day out to try and solve complex, hard problems that you might see in the news of like, oh, carbon capture is not there yet, or solar power is not there yet. When we hear that, you are the people in the background trying to figure out, well, how do we get there? And I think that when we talk about research, certain people fall off and they go, I don't even know what you're talking about anymore, or that like I've never done research in my life, or they think Googling something is research in comparison to what you're doing. And so can you kind of situate us in the value of research within your field and how that contributes to the understanding of the scientific community has, the broader impact of researching things and contributing to that body of knowledge?
Yeah, that's an excellent question. I feel, a traditional model in academia has been publications and conference presentations to disseminate the results that have been found. And, I still strongly believe in that model. It is important because, as and when discoveries are made and new ways of thinking are incorporated, then, it's important that the community is aware of that, and through publications and presentations and conferences, patents, those tools are still ideal. But I feel that there are cases, right, where there's been a publication that for years no one paid attention to, but then 15, 20 years later, suddenly people see that, okay, this now in this given challenge, someone had published about this in the 1980s, which may be applicable now to the situation. So, I feel that there's always that impact that publications and traditional methods have in the academic community, but also to be cautious that, hastening that dissemination to a more general public audience does take time sometimes. And when there is some kind of impact, it's widely accepted that this technology or this research is widely applicable, then a lot of universities have news articles that come out that sort of explain that in a more layperson's terms so everyone understands it. And that should still continue. And I feel that's where universities and organizations, they pick up some of these news articles, they disseminate it, and everyone is able to read. So, BBC News, for example, following the science page there, New York Times, all of these now have dedicated science pages where they synthesize all of the scientific research that's been done in an area and they present it in a very understandable way.
Right. So how do you think that research or funding is at all like an issue? Like, do we have enough funds coming to organizations like yourself to make sure that we're figuring out these problems as fast as we can? Because when we say the word like climate crisis, which I think is the latest kind of term, it's meant to invoke something out of the person. And so if I'm willing to accept that and say, okay, there is a climate crisis, I want to make sure individuals like yourself and organizations that are trying to figure out the solutions are properly funded. But that's something I don't hear in the news. So do you feel like we're on the right track? Do you feel like we're funding problems properly? And how does funding work? Do you guys get like given a problem and then a certain amount of money to try and solve X problem? How does that all function?
Yeah, so funding is it drives research, and it is we cannot escape that. We need equipment to do research. We need materials. We need to provide, and that's again things that you would buy with your funding. And traditionally, professors and academics would apply for competitive grants that are offered by various levels of governments and the public sector. There's call for grants, and you put in a grant application, and it's a competitive review process against other faculty who've submitted, and it's a fair process that's followed. And if you get the funding, then it is sustainable for some time. But also, other models have emerged where industry, for example, companies have a specific scientific problem that they want to address, but they don't have the resources to do that. So that is something that my group, we've been actively pursuing, where we have conversations with local industries and see, if there's a specific scientific need that we can address in our labs. And there's a great benefit that, the industry benefits if, let's say, in a 2-year window, some of those challenges have been addressed with the scientific process. But even if, let's say, it's not a direct impact in their current process, just the science and knowledge that's gained from that is very beneficial to a graduate student who's on that project. But also the graduate student has an interactions with the company. They can spend time being mentored by the company in addition to being mentored by scientists and academics. So I would say that model has been here in Canada, and it's been great. A lot of universities have those connections with local industry.
Okay, so I'm interested. I had Carrie Lynn Victor on. She's an artist, and one of her challenges that she described is that she has like visions in her mind of things like artwork that she wants to create, and it comes in a 3D medium in her head, and she needs to turn it into a 2D medium, but those are personal to her. And so there isn't a huge market for her to promote the ideas that she has in her head, because somebody comes to her and says, I want you to paint like a bird, and I want this bird to look like this. And then she has to follow what the consumer wants rather than what she wants to do. Is there any concern with that within academia, that governments are telling you, this is the grant, this is what you're applying to participate in, and so maybe the research that you're interested in doing or that you think would be valuable isn't something that the grants from the government are coming from or industry is interested in? Is there ever a concern about like, well, we want to focus on this, but there's not really a market for that for funding right now? Is that ever a challenge?
Well, that's an interesting point. It's, there is a role that governments, when they offer research funding, they understand that research is a slow process, and there is risks, there are things, but if there's a reasonable scientific or a reasonable process, not just science, even in humanities, a reasonable process has been followed to have a hypothesis driven approach, and then gathering evidence and data, and then reaching a conclusion, then, as I mentioned, even if the impact doesn't seem obvious right away, if it is out there in the public domain, I strongly believe that someone will find the impact of that many years later. And even if it isn't, it's still great to have that as part of the public domain. And that's why grants. There are grants that do recognize that there might not be an immediate sort of end use or impact, but if it is following a systematic process, if we show evidence that there's big benefits that are coming to Canada. There are evidence there, also with students, and that's something that a lot of grant applications want to emphasize. That how are the students benefiting from this? What is the mentorship philosophy? What are they getting? And those are all incorporated in some of these funding models as the overall case that you make for your impact.
Okay, so if there was like a lot of support for something like carbon capture, and that's where all the funding was being directed towards, but you were like, maybe this is useful to research something like sulfur or something like, is there ever a challenge of you saying like, I want to research sulfur, and they're like, well, no, we want you to focus on carbon capture because that's what we're putting out money for, and we're not interested in that. Even though, as you mentioned, maybe that's an even more deleterious issue that could be resolved if you were able to focus on that, but maybe the money's just not there for that. Is that ever a challenge?
Well, so you could look at the mandate of in any country, like a government that is funding research, they want to encourage innovation in labs that are in government labs, but also in academic labs. And they realize the importance of diversity in research. And, there are important hot topics, as you mentioned, but there is also specific research expertise that is very rich in Canada in certain fields. And if, there is enough evidence that a research program is able to incorporate, innovation in that area, but also significant training of students so that they can launch into successful careers, and also, incorporate elements of interdisciplinarity and collaboration, then if you put yourself in the shoes of someone who's in a government level funding that, then it feels good to fund those kind of programs, even though they may not fall into a very hot topic there. But then there are also organizations that may have a specific mandate. So, if there is an organization that is specifically interested in, let's say, sulfur removal, and that is their mandate, that is something that they want to pursue, then they would have a grant application that would be very specific to that, and it would invite qualified researchers who have the expertise in that to bring to it. So both of those models exist, and they're good.
Okay, perfect. Do you think there's anything more that individuals can do, maybe listening or just broader, to support research that's going on, to support our development of understanding of these tools, whether it's solar, carbon capture, trying to do these things? Is there a way they can support that? Because I know that there are plenty of ways to support like Tentree and consumer products, but is there a way for people to show their support for research that's taking place?
Yeah, and that's I've always thought about that. There's a mandate that for researchers to make sure that their findings are communicated as broadly as possible, and that's where if there is a reception with the layperson that they understand and they are interested in being part of that dialogue and conversation, then in having them participate in lectures and talks that faculty give and not being hesitant to ask questions related to that is one avenue. Another way would be as students, right? So students who are interested in a certain area and they feel that they may have the tools from their upbringing and education to contribute but still want to learn. And a lot of times professors and academics realize that, and they want to be able to provide resources. As I mentioned, outreach programs. There are labs that do let's say like a couple of weeks where students can come and spend that time working, being mentored by a graduate student and being part of a formal program. So that's where they're also being more involved in this process. And a lot of like labs around the world have started to have things like maker spaces or like fabrication centers where people can come and build things and 3D print things, and that way they can design, and then themselves, let's say if they wanted to investigate an idea but didn't have the resources to do that, then having a space where they can make things, build things, brainstorm ideas is great. And that's something I found very motivating at MIT. I feel MIT is doing a very good job there in having maker spaces, open access. A lot of this movement of having courses that are taught at MIT that are now openly available around the world at no cost, and students can do the problem sets that MIT students are doing is just very inspiring. So that way, I would say that those are some avenues.
Yes, I'm very optimistic that the podcast space is allowing people to kind of open their horizons to what they're interested in. Because if you had have asked me in my undergrad whether or not I'd be interested in topics of engineering, you can bet that I would have said probably not. But listening to individuals like Lex Friedman, individuals like yourself, it's like, this is valuable knowledge. This expands my understanding of how the world works, how to think about things. Like I had never even heard throughout my education in my bachelor's degree of thinking in first principles.
Right.
And I find that once Lex Friedman broke that down and Elon Musk, it was like, I've never even considered that there's a whole different parallel way of thinking about problems that I hadn't considered before. And I think that it's a sign of optimism that so many truck drivers are able to listen to long form podcasts, because I would say that perhaps we underestimated their intelligence. Perhaps we put them in a category of like, well, you have this job where you're just steering a vehicle. Maybe you're not as smart as someone in MIT, but now you can listen to Lex Friedman when you're a podcast driver and listen to complex engineering problems. And he interviews some very intelligent guests where you go, whoa, I really don't understand this world as much as I thought.
That's amazing. And I should follow. And, just like you yourself have started this, podcast where you're right, there's, appreciating the dignity and that everyone is, in a role that they, based on circumstances they pursued, but that doesn't mean that they can't stop learning. And if there are means like this kind of conversation where they're able to, break down some concepts, get some clarification, but also very importantly, have access to experts when they need. And, I'm very encouraged to see in academia that model is emerging where, academics are realizing that let's be more accessible. Let's try to have more conversations with people who, just are curious about science. They want to ask questions. They want to know, in, the simplest terms, what's going on. So, podcasts like these are a great means for that. And also, just open access, like coming to, a lab and seeing what's going on and having that kind of enthusiasm that there is a space where they can learn as well.
Absolutely. And I think that this type of approach hopefully breaks down any polarization that occurs on important topics, because you're in your lab, you're working. It's not a big conspiracy when you're in there working with students. Like, this is an educational process where people can learn. And I think that that's one of the detrimental effects of specifically social media, is that you can end up thinking that like the world is flat or these unreasonable, untenable ideas. But hopefully podcasts where people can see you, they can see your body language, they can have more confidence in the information and absorb it more than perhaps like a National Post article or something where it's just words and it doesn't resonate the same way as you just kind of explaining the process or from your understanding what's taking place. I think that it's much more personable, and I think that based on how we've developed as human beings through the evolutionary process, this was how we were meant to consume information.
Right. Yeah, very much so. And, you bring up a great point about credibility of information and, social media. There's, it's amazing how, some groups can go to take vast efforts to prove or disprove a certain point. And that's where, this emergence of, evidence that is not, or fake news and things that are not scientifically relevant come in. And it's important for, experts to also have their own consortium with which they can interact and give that. And I feel, SFU, that was another thing that really attracted me there, because SFU's motto is, engage the world. Let's be part of the community. Let's work with, local communities. Let's work with nonprofit organizations. And I, if you've never been, I would encourage you to come to our building. It's in Surrey. It's the new building for sustainable energy engineering. It's, glass walls. Like, it's meant to sort of be welcoming, to show that, what we're doing is open and we're truly part of the community. And yeah, it's also nice to have that, open space where sunlight comes in, and in post-COVID worlds, it'll be booming with activity.
Yes. Do you have a place where you want to take that organization, support it in a certain way? Do you guys have certain like 5-year goals, 10-year goals that you hope to try and accomplish certain things within the academic world?
So you're asking specifically with SFU, with the organization? Yeah. So, the mandate of universities has always been to provide that degree of education. And even now with the COVID pandemic, we've seen that, education cannot stop. We still have to continue giving the lectures and making sure that we use the resources we have to make sure students are learning. And that motto is still going to be reflected in the next 5 to 10 years and continue to do so. And that's why, with the gravity of certain problems that are affecting us are incorporated in some of these mandates. So, for example, SFU has made a big mandate on commitment to sustainability to start with, SFU's own campus and how it can, look at ways to become more sustainable, but also specifically our program as well. And infusing all of this in course projects, when students are working on their capstone design projects, where can they have an impact? Where can they work with the community? All of these are important considerations as well as we grow.
Right. Can you tell us about your work? I believe it was with Indonesia.
Oh, right.
Can you tell us about what happened there and kind of the journey of how that started?
Yeah, that was the end of 2017, and at MIT there's a program it's a fellowship program where students, if they want to pursue a project in any place in the world and have an idea where they think they can have an impact on the community, they can apply for this funding that provides costs for traveling and then gives some additional funding for the community. So this project was with an organization in the US called the Give Light Foundation. They have orphan homes in many parts of the world, but specifically in Indonesia after the tsunami in 2004. There was an orphan home that was established in the city of Takengong, where providing care for orphans and this was 15 years ago, but since then they've continued that mandate that there is a need for an in-depth care and providing that level of care that any family would in a caring family home. And there I was interested in, and again, more of sustainability. So my thought process there was, if an orphan home can become more self-reliant and, produce their own energy, produce their own food, then that way they are minimizing their costs, which means that they can, support another orphan. And that way they can, expand their capacity or use those funds to, benefit there. So it started with a very simple project. It was the idea that biomass combustor or biogas generator, where you can digest some of these waste that you generate, can cause methane, as we have talked about. But this methane can be used to generate cooking gas, and then it could be used to power to run simple operations like cooking, heating water. And in a lot of ways, you could think of this as being sustainable because they're using their own waste in a cyclic process and then recycling this. So I helped and I set up one of those biodigesters there. But also main learning is that it's very important to see the needs of the community and make sure that the community actually needs this and they're able to sustain this throughout that time, which is not easy. And it requires, understanding, where the hesitance comes from. So, a lot of times you may see people saying that, let's go install solar panels everywhere in communities and let's assume that it's going to run. Well, it's very important to understand that if the community, do they have the resources to operate this? Do they have the understanding? And if you left, then are they able to operate this by itself? So that was a main takeaway from me from that experience. The biodigester still provides, the resources there, but it can be hard to sustain because the climate in Indonesia and that place is varying, and based on the climate, it may not digest at a high efficiency. But encouraging students or the orphans there to be sustainable, to understand that they want to reduce food waste was great. But also just feeling that that love and that enthusiasm, being with them and being part of that community was great.
Yeah, and trying to find a way to, because it's not always going to work, but it's so valuable for people to try and bring their scientific knowledge to communities, even if just for a display of like the effectiveness and the impact and the value of scientific understandings, because there has been innovations, and often impoverished communities or communities that are struggling are the least likely to get access to that information and feel discouraged at the idea of going to university or something. So having the opportunity to meet someone like yourself and have you bring this technology that I'm sure would boggle my mind in like, what is this? How does this work? That's valuable in and of itself to understand that the world world is a developing place and that there's new understandings that we have on how to utilize certain resources in a more effective way.
Right, and that the takeaway being that any community around the world has needs, has operating procedures that have been established years in that community that you may not know as someone going externally. You can try to get as much knowledge there, but it's not easy, and that's where having allies in the community to work with and truly understand the need and making sure that it is applicable was the main learning, and that's something that's also very important here, right? In remote communities across Canada as well, where there's operation with diesel and replacing this with sustainable technologies is attractive. It's great, but the acceptance and the sustainability and the long-term impact has to be looked at.
It makes me think of water treatment plants in Canada in terms of Indigenous communities, because there's a certain arrogance that I see with at least the NDP government federally that says we just need to fund these programs. We just need to give them water treatment plants. It's simple. And it's, well, first of all, these are remote communities.
Right.
Second of all, they don't have the engineers to maintain these buildings. And from my understanding, that's what I went to the NLC program in Saskatchewan.
Okay.
And they had developed a water treatment plant. And one of the challenges they faced was they didn't have the community knowledge to maintain this plant.
Right. What is this program? Sorry?
The NLC program was the
Okay.
Native Law Center
I
program.
see.
And so I
Okay.
took a property law class there. But one of the individuals speaking was just like explaining that one of the challenges they had is how do we, when we're a struggling nation trying to just support ourselves with the bare minimum, we don't have like huge economic development, so we're on a limited budget. How do we not only bring in engineers, but pay them what we would need to pay them in order to
Right.
come move here,
Right.
live here, maintain this plant
Yeah.
long term to get
Yeah.
commitments out of people?
Yeah.
And so that's something where I think even at a national level, governments can kind of sell you on this. Well, like why don't Indigenous communities have clean water? It's such a simple problem. Like,
Right.
and they kind of make it like a race issue. And I want to avoid that. I think there's a place for that, but I want to avoid that if it's inappropriate. And in that circumstance, after learning about the challenges of bringing in engineers and the cost
Right.
with that, you need to have that humility of maybe it's a harder problem than you're estimating. Maybe there's larger challenges
Yeah.
that you're going to face in terms of making sure you have the funds to maintain that water
Absolutely,
treatment.
yeah. And that's where an interdisciplinary approach is becoming more and more important, where, there are experts who've invested a lot of their academic time in understanding communities and understanding the history and developing that trust and making those networks, which have to play a role in an overall project. And that's something even in my research group we're interested in applications of some of these technologies in remote communities in Canada, and realizing that working with faculty and an organization that have built that trust, that level of connection is very important, and it has to be part of the overall process, and it should not. One of the things again I learned from Indonesia was it was a 4-week project. It was a very crunch time frame, but also accelerating something for the sake of getting a project done without doing a full picture analysis is not ideal. So spending that additional time, and no matter how much time it takes, it's important to invest that time in making sure that technologies are sustainable. There's enough need consideration that is given, because as I started by telling you, right, ultimately engineers are responding to a need, and if that need is missed and if something is enforced, then we are deviating from that principle.
Yeah, I don't disagree. And again, it just gives me optimism to have individuals like yourself having that multidisciplinary approach. And I read that in the Peak article that I saw of you, that was one of the cornerstones of your approach. And so I think that gives a lot of optimism to me to know that there are individuals like yourself out there. Where do you hope to go over the next 5 to 10 years? Where do you hope to kind of take all of this? Is there like a particular area of interest you in terms of research that you want to focus on? Where do you hope to go?
I'm very passionate about the research I'm doing. I love, being with students in the lab and, working on these nitty gritty chemistry, materials challenges. So I feel that I still want to continue doing that over the next 5-10 years, have publications, have discoveries, have conference presentations, and continue interacting with faculty. But also, and as I mentioned, I keep a close heart to policy. So I did a program recently with the government. It's called Action Canada, where our cohort has it's 18 different fellows from all across Canada and in different sectors. We have lawyers, we have doctors. I guess I'm the professor. So they put this team of individuals together, and the idea is that let's work on a important policy challenge that where we can bring this multidisciplinary, diverse perspective while also developing as leaders and as thought, making our own, teamwork and ability to work in a multidisciplinary team stronger. So I do want to continue doing, having opportunities like that, and keeping still close ties with government in terms of Natural Resources Canada, where I've worked, and yeah, and then through that, possibilities are there. There's possibilities of students in my lab going and working in the government, for example, taking that time as an internship, and providing that mentorship there is good. But also, I just love teaching. I just love being in that role, and in that educational role, I feel I can magnify what I have learned and then transmit that to many students, and then that feels good. So I would see myself continuing that.
As somebody who attended school for such a long time, is there any experiences that you had that made you want to approach perhaps educating differently than maybe some of the professors that you had, or some of the educators where you were like, I want to do it more this way, or I want to make sure that I don't repeat this negative experience I have?
Yeah, and there's always pedagogical research which I keep myself updated with, but also the peers in my program, just learning best practices from them, and in the pandemic that showed, right, with like how do we transition to online learning but still keep students enthused and still have a degree of educational pedagogical delivery that is replicatable in a classroom. So I would say something as simple as recording lectures. It's something that the pandemic has shown is very effective as a way to learn, because some students want to take their time and go and look at the lecture content again. They might have missed that during the lecture, but in a traditional classroom model, traditionally classes were not recorded, so that that was that additional pressure on students that whatever you see in the class in that lecture time is what you should note, and if you missed it, it's too bad, right? You just have to find a way around it. But now with this recording model, you can do that. So yes, I feel it is important to continue developing as a teacher, and student feedback is always great. So always I learn from feedback that I get from students when it's constructive, and it's important to keep developing after that.
Right. What is your relationship, I guess, with the environment? I'm just curious because you have like this deeper understanding of what the heck is going on. Do you enjoy going out in nature? Do you have like an admiration of the natural environment, perhaps deeper than the average person, because you understand what's going on and the consequences if we don't handle this properly?
Not particularly. And I would feel I'm like, anyone. I would say that, if I am in a beautiful place like Vancouver, where there's so many opportunities to go out into nature, that's, something everyone to some extent enjoys being part of that. And I feel very much in tune with them that way. But yeah, it is important to appreciate, because, sometimes you may go and visit a glacier, and the reality is that you may realize 40 years from now that glacier won't exist because of climate change, and already, things have started to recede. So it does sometimes help to put that, and this can, not just me, but anyone, right? If anyone is enjoying nature, and if they go and realize that these are the things that are going to be happening in the next 50 years, and it sort of reinforces your own motive, and enforces sustainability. So I would say that in a lot of ways, all my friends, everyone sort of embodies that, and we should all continue to. And it's great to be in a place like BC and Vancouver, where you could still see pristine nature that is still unimpacted, and just feel part of it.
Right. Do you look at all like places like, I don't know if you've kept up with what's going on with Fairy Creek, where they're trying to, I guess, deforest that area and there's a bunch of protesters. Do you have any perspectives on those kind of current events where you see another one is like Indigenous communities fighting back developers or stuff like that? Do you have any perspective on that that might be nuanced in comparison to the kind of dichotomy we see between development and keeping the natural environment?
I would say from a more engineering perspective, it is something that, as you know, the engineering process for a project includes a big focus on the needs of the community and the impact on the immediate environment and broader, and that is. I would frankly say it is a mandate of any project anywhere, any development project and mining project. It is important to give that full picture consideration, and there have been examples of projects that have run for many years in a community with enough trust between the community and the project, and enough trust that what's going on in the environment has been reasonably accounted for. And a lot of times that happens if the team is diverse, is including members that can give that perspective to people who are doing the math and the design, that hey, make sure that this is also considered. And I strongly believe that in a diverse team, and by diverse, you could comprehend this as diversity in education, but also diversity is reflected in our population. All these perspectives can come to the table, and then they can start to become more sustainable and more the trust level that would be higher.
Right. Can you tell people how to find you online? I believe you might have a website, and I think you're primarily on LinkedIn.
Yeah, so actually my website right now is down, but hopefully it'll be back up again. It's khanresearchlab.com. That's where we keep updates on our research and students who've joined. But also LinkedIn. I'm quite active on LinkedIn. So my full name is Sami Khan. So if you find me on LinkedIn, please follow me or add me. I'm not as active on Twitter, hoping to start that soon. But yeah, if it is, then it'll be on my website.
Okay, perfect. I really appreciate you being willing to take the time, because I do agree. I think science communication in this way, I think it's the future. I think that this is hopefully really easy for people to digest when they're cleaning their house or on a bike ride or something. I think it's a way for people to kind of engage with important topics. I think that for many British Columbians, this is an important topic, but from someone I would consider a very trusted source, a very reliable source, your education and the work that you've put in the background to be here today to help inform not only government officials, but the general public, I think is so valuable. And your passion for sharing this information with students, I think it gives me a lot of optimism, because I think that's who I would want educating our next generation on how to do things better, is the people who've worked hard, who've been to the best schools and have come back and decided to share that with Canadians. And I think that deserves more recognition than I think it gets at times. I think that just stopping and going, wow, like there are individuals in the scientific realm researching, reviewing papers, writing enormous booklets of information that get reviewed, that don't reach the general public, but it takes a lot of work to do that and to share that information. I think it sets a good example, and it's people we should aspire to be more like. And I know in China, they've done a good job of making sure that the science educators like yourself, they're at the top of the TikTok algorithms, they're at the top of the YouTube algorithms, because they want their populace to be more educated.
Yeah.
And I think we can learn something from that, from interviews with people like yourself.
Well, thank you, Aaron. This is very humbling to hear you say that. And, I feel that, being in company of inspirational people like you yourself and, students who I learn from every day is always great. And yeah, actually, you mentioned this point. So NRCan, Natural Resources Canada, has an Instagram called Simply Science, where they want to engage and showcase the great work that, government scientists are doing. So I'm very happy to see even in our government that those initiatives are starting. And I'd encourage everyone to subscribe and keep a tab on some of these social media accounts. But also, very much, I feel like everyone in this effort has a role to play, and there's a team effort. And, as you mentioned, scientists who are churning out papers are very devoted. I really appreciate their work, because they have a mission. There's only 24 hours in a day, and they've devoted that time for it, and that deserves respect there and that acknowledgement. And likewise, anyone who has taken a degree, in another field that may not be directly related to climate change, but they're aware of it, they're incorporating that, they've made, the friends and contacts, they're having conversations. I feel that it's important to, appreciate that and realize that, not all of us have to be the same way, but we all have, those friendships and connections that help us get through it. So yeah, and I feel very happy that you considered to invite me to be a guest, and yeah, thank you very much.
Yes, it was. I'm very grateful you were willing to drive out. I know that it can be a long drive in the morning, but we just did 2.5 hours.
Oh wow, yeah, time flies.
Yes, thank you again for coming.
Yeah, I'll be happy to check out Chilliwack in this afternoon. Is there anything fun? What would you say?
Yes, I would recommend checking out probably Harrison Hot Springs and Yarrow if you can. If you're on your way back, I would check out Yarrow. Those are two smaller communities that are beautiful and I think have a lot of the culture.
Yeah, and actually the hot springs is an example of geothermal energy. So the reason they're hot is because of this energy from the planet, and it's used to heat water, which is a great example of geothermal.
And I think they have a high concentration of sulfur, if I'm not mistaken.
Well, there you go. There's all these things that cause corrosion and stuff, so I'll make sure I don't get corroded.
Yes, and hopefully that makes people more interested in the world around them and appreciating all of these unique events that kind of take place.
Yeah, and right here in BC, and it's just great to be here and see that there's just so much potential here in BC itself.
Yes, thank you, Sami.
Thank you, Aaron.